college. This is a week-long crash course on analog and digital electronics. I congratulate the Department of Computer Science and Engineering for conducting this event. I wish all the success for each and everyone who are participating in this event. Engineering branches, UG branches in our institution. We have also, if all the departments are guiding students for their doctoral degree also. Ours is a 52 acres campus situated very close to Bannerghetta National Park in South Bengaluru. We have very good infrastructure. We have more than 10 lakh square feet of buildings infrastructure, and also we have a fantastic library facilities wherein we have 75,000 volumes and 20,000 e-library facilities wherein students can log in from their homes also. Our institution is, the founder of our institution is Dr. K.R. Paramhamsa, a true educationist. He is our chairman, and it is backed by our vice chairperson, Srimati Geeta Paramahamsa, Ms. Monica Kalluri, vice president, and Mr. Rahul Kalluri, executive vice president. The main backbone of our institution is our teachers. We have 250 plus teachers in our institutions. Most of them are doctorates, and the remaining people are also doing their PhD in various institutions and also under PTU. Our staff members and the people who are registered for PhD have published more than 350 publications in the last 1 year itself. We have more than 7 patents in our institution backed by our staff members. I once again wish all the participants to utilize this 1 week in getting all the necessary things that is wanted by the students of Vishveshwaraya Technological University. I wish you all the best once again. Thank you for giving me an opportunity to speak on this occasion. Over to Dr. C. Lata, Head of the Department of Computer Science and Engineering, AMC Engineering. Thank you.
Hello my dear students and proud parents. This is Dr. Lata, heading Computer Science and Engineering Department in AMCEC. Over the past 2 decades, the department has grown leaps and bounds to become one of the pioneer department under VTU by securing 11 VTU ranks. We pride ourselves in academic rigor, excellence, discipline inculcated to the students by a highly qualified and experienced set of faculty members, among which many are doctorates and actively pursuing research.
Hey, I'm Shayan. And yeah, the classes can get boring at times, but the faculty at AMC emphasize creative learning with ICT tools and project-based learning. Each faculty provides their own web link where you can access course content, notes, and other material. For the latest academic content, the department has its very own app called CourseSmart. Our students have won numerous accolades, including the Best Student Award under ISTE, and even recognition from NASA. Yep, the one in the USA. We even have our own forum, the Intellects Forum, which is of the students, by the students, for the students, with guidance from the professors, of course. Under the forum, we conduct numerous technical events, non-technical events, and even exciting brainstorming sessions. We think you're going to love them.
We are near one of the 12 labs under the department, among which 2 are centers of excellence. One is by well-known Cisco for networking, another one is by TechVet for Internet of Things. It also has 3D printing technology to make your product ideas come into life. We periodically conduct international conference, hands-on workshops, faculty development program to keep both the faculty and the students abreast of the industry requirements like blockchain technology, augmented reality, edge computing, so on.
Hey everyone, I'm Shravani Ghosh, an undergraduate student at AMC. We are home to a community of leading research and teaching. This place right here is where we usually have our lab sessions along with value-added certification programs like AWS, Blue Prism, Cisco networking and many more to make you all industry ready. Okay, now if placements are a concern for you, let me make it clear that our college provides industry-specific upskilling along with the personality development and software training. Okay, this makes it easier for the companies to hire you. You just gotta make sure you meet the eligibility criteria, that's all.
Regarding this workshop, if you ask your seniors, they would all say that among 8 semesters, 3rd semester is the most toughest. And in that 3rd semester, ADE, that is Analog and Digital Electronics, both theory and practical is supposed to be the toughest of all the subjects. So, but it appears like that. It is not the actual fact. If you go to the subject in detail, try to understand it, then it wouldn't appear as difficult as it looks like. So we thought we will have a revision as the exams are approaching, detailed revision, not just like you just turn the pages, detailed revision for all the students. And VTU was very magnanimous in sponsoring the event also. So we thought all the colleges students of 3rd semester would be benefited by this workshop. And we have Professor Jaishubha ma'am and Professor Shalini ma'am who have been teaching this subject for quite a number of times. I think Jaishubha ma'am has taught it for 10 times and Shalini ma'am has taught it for 8 times. So they are well versed with this subject and I felt they are the right persons to take up this course. So I welcome Jaishubha ma'am also, Shalini ma'am also to this crash course of 5 days. And I wish you all get benefited as expected and you all would score very well in ADE subject and both theory and practical. The last day will be dedicated for practicals and they make it very interesting and very easy for you all to understand the topics and subjects also. So please make use of the opportunity given and come out with very good marks in both these lab and theory subjects. Okay, thank you all and over to Jaishua ma'am and Shalini ma'am.
Good morning, everyone. I am Professor Shalini from Computer Science and Engineering Department, AMC EC. I am pursuing PhD in BTU at MSRIT. I have more than 10 years of teaching experience. I have handled this subject many times. We request all of you to work problems when we are discussing. Please be present for all the sessions with pen, paper. Over to Professor Jaishivam.
Morning, everyone. Hope you are audible. Yeah, I'm Jaishuba, working in AIMC since 10 years. I'm basically BE graduate in Electronics and Communication and MTech in Information and Communication Technology. And now I'm pursuing my PhD in Electronics. So as a beginning, we'll start with the importance of ADE subject, because many people who are in computer science, many students, they feel why at all we should study ADE, or that is analog and digital electronics. But computer itself is a product of electronics. So first you all should understand that computer could be developed only due to the advancements in electronics. So if without knowing the alphabets of computer, you cannot be a good computer engineer. And also along with that, for the current trending subjects, that is IoT, machine learning, AI, all these are basically, they need the very basics of analog electronics and digital electronics. So unless you know the basics, you cannot be a engineer in the trending topics like IoT, machine learning, robotics. So all these need the very basics of the electronics. So the topics are such that in the syllabus, the very important topics which lead you to understand the computer better and make you better computer engineers. So this is the importance of analog and digital electronics. So when you start hating a subject, that itself will become a big mind block for you. So please see that you don't hate any subject, because it is one of your curriculum for completing your degree. Just have liking to all the subjects so that you can excel in your degree, right? So with this, I hand over to Shalini to begin from the module 2. So first we'll be covering module 2, that is digital electronics, all the 4 modules. And the last day we'll be doing the module 1, which is analog electronics, right? So we all request you to be interactive, and whatever problems we are solving, you also parallelly solve so that you can gain the complete knowledge of the subject. Thank you all.
Okay. Welcome you all to the world of digital electronics. So we shall start with module 2. I request all of you to take this very sincerely and attend all the sessions, and please work out the problems along with us. Otherwise it is of no use. Please have book, pencil, pen, paper with you. Yes, I'll give you a few minutes of time, and be ready with your book, pencil, pen, eraser, scales. I guess all of you are ready with pen, pencil, books? Yes? Okay. It's a crash course on analog and digital electronics. The subject code is 18CS33 and 18CSL 37, that is theory and lab. And this workshop is sponsored by Vishweshwaraya Technological University for the benefit of third semester students. So we shall start now. So we shall see what we are going to discuss on the first day. The schedule is morning session. We are going to discuss fundamentals, K-maps, grouping in K-maps, don't care conditions, MEV method. And in afternoon session, Quine-McCluskey method, Patrix method, question bank discussion, exam paper discussion. So this is the schedule for the day. So first we shall understand what is the signal. There are two types of signals, analog signal and digital signal. There are two types of signals, analog signal and digital signal. So analog signals are represented by sine wave that you already know, and digital signals are represented by square waves. So what are these signals? Signals are electromagnetic waves or electric current that carries data. You know what is data? Data is nothing but information. So the data moves in the form of sine wave. Here, the data is converted into bits in case of digital waves. So where did we use analog waves? We used analog waves in telephones, which we used about 10 years back. And today's phone, what we are using, mobile phones, they use digital signals. Okay, you have already seen in your syllabus that the analog waves are represented by sine waves and digital waves are represented by square waves. Now coming to the fundamentals, we have stop and pause expressions throughout the syllabus, and they play a very important role in your syllabus. SOP is sum of product, pause is product of sum. When we want to represent a expression, we are taking function of a comma b comma c, where these a, b, c are variables of this expression. Here you can observe that we have a dot b plus bc complement plus ac. Sometimes this complement is also called dash or bar. If nothing is mentioned in between two variables, it means we are using AND operation. By default, it is AND operation. So here it is A and B or BC complement plus AC. So this is how we write SOP. Coming to pause, we have function f of x comma y comma z, where we are taking x or y and y or z bar or complement and x or z. So this is how we represent SOP and this is how we represent pause. If you go wrong in understanding this SOP and POS concept itself, you cannot solve any of the problems in analog and digital electronics. You should be knowing what is SOP, what is POS. Okay, and coming to the representation. So min terms are represented with the symbol sigma m, small letter m. Max terms are represented by pi m. Min terms are used in SOP, max terms are used in POS. Always remember, min terms are used in SOP, max terms are used in POS. So this is how we are going to represent the function f of a comma b comma c, that is equal to sigma m 0, 1, 2, 4, 5. So these are the set of min terms we are considering for the function f of ABC. Okay. Coming to the max terms, f of a comma b comma c, pi of m 3 comma 6 comma 7, that shows that these are the set of max terms that we are using for the function f of a comma b comma c. And one more thing I want to tell you, in an expression, say this is an expression a dot b plus bc bar plus ac. If you consider this expression, each variable, each letter is called literal. So without understanding these terminologies, it is very difficult to move ahead in analog and digital electronics. Now coming to the question, what is standard canonical formula? What is standard canonical formula? I hope you're all thinking on that, right? So what is standard canonical formula? Suppose I include all the min terms in an expression. Suppose I include, say, if I have an expression f of a comma b comma c, then if all the literals are present in all the expressions like this, then such an equation, such an expression is called standard SOP, because all the variables which are present here are shown here. Suppose I take this equation a comma b comma c, that is equal to ab plus ab dash plus abc. Okay, so then this doesn't form a standard SOP. Why? Because here you can see the literal C is missing. Here also you can observe that the letter C is missing, right? So it doesn't form a standard SOP, standard canonical formula. So such type of expressions are called canonical formula. I hope all of you got the concept of SOP and POS, right? Okay. So how to draw circuit diagrams? By this time, you might be knowing which are the basic gates and which are the universal gates. The basic gates are AND or NOT, right? And the universal gates are NAND and NOT, right? Suppose I say A or B. How would I write the circuit diagram? A, B, and here you are using OR gate. So this is the output, right? This is how you write the circuit diagram. Suppose I want to write like this, A or B into B plus C. How would you write the diagram, circuit diagram? So I'll take like this, A, B, C, right? And I'll draw like this. So this is A or B, and the next one is B or C. Okay, and then here we can draw using AND gate. So which are the gates we used here? We used OR gate here and we used AND gate. So this is how you need to write the circuit diagram. It plays a very important role, and these things we have already taught in the online classes. The importance of circuit diagram also you have told. So at the end, we are going to end up with circuit diagram. The main aim of analog and digital electronics is to get a proper, efficient circuit diagram, right? So that we are going to get the proper results, right? So this is how you have to write the circuit diagram. It is just a revision what I did, because these things you are studying from your basic electronics from first year, right? Coming to the truth table representation. We can represent a function using truth table. I already told we use sigma m for min terms and pi m for max terms, right? And the truth table is represented with a combination giving different values for the variables. I'm taking A, B. So here I'm giving different combinations 0, 0, 0, 1, 1, 0, 1, 1. So you know that this is so this is 2 raised to 0 and this is 2 raised to 1 position, right? So what we want, 0 and 2, right? So what we are doing here, wherever 0 is present, we are marking it as 1. This 0. See, this is equivalent to 0, right? Then this is equivalent to decimal number 1. This is equivalent to decimal number 2. And this is equivalent to decimal number 3. 2 plus 1, 3, right? So which are the numbers that are mentioned in the function? The numbers that are mentioned in the function are 0 and 2. Okay. So for 0, I am writing 1. This is 0, right? And for 2, I am marking it as 1. So this is how you need to write the truth table for min terms. So coming to max terms, you just observe we have the same truth table, but the values for the function in the last column are different, right? So pi m, when we use max terms, we have to put 0, okay, wherever the values are mentioned. So this is again 2 to the power of 0, 2 to the power of 1 positions, and it is 0, 0, 0, 1, 1, 0, 1, 1, right? So here both are zeros. So 0 is there. So mark 0, not 1. You have to mark 0. Okay. Then coming down, 2 is there. So mark 0 there. In remaining places, you need to mark 1. In remaining places, you need to mark 1. I hope all of you got this. Yes? Okay. So you try with your book and pencil. If I give f of A, B, C, that is equal to sigma m 0, 2, 4, 5. Represent this function with the help of truth table. I'll give you a few minutes of time. Please write this function with the help of truth table representation. Even these are fundamentals which are very much required. So now coming to module 2, we'll start with the module 2 syllabus. Till now, I told you about the fundamentals which are very much required for you. So we start with K-maps. K-maps are also called Karnaugh maps. They are used for simplifying Boolean expressions. The Karnaugh map reduces the need for extensive calculations using various Boolean laws and theorems. So two variable Karnaugh map. A two variable Karnaugh map can be represented with 4 cells. Suppose you want to write a K map for 2 variable, you are going to write it as 2 to the power of 2. Okay, that is equal to 4. So this represents 2 to the power of 2. The power represents the number of variables. Power represents the number of variables. So 2 to the power of 2, that is equal to 4. Okay, so now this is how we are going to represent it. So we need 4 cells. We need 4 cells. So the numbering must be done like this: 0, 1, 2, 3. Okay, 0, 1, 2, 3. Okay, so here we are mentioning the variables which we are using. Okay, so I hope you are clear with this. Then coming to 3 variable map, the 3 variable map is represented like this, and it is given by 2 to the power of 3. 2 to the power of 3 is nothing but 8. So we need to have 8 cells, and see the numbering. It should be followed like this only. Don't do any mistakes. So 0, 1, 2, 3, 4, 5, 6, 7. Numbering of cells very important. And here we are taking x, y, z. Okay, it is 0, 1. Okay, so next coming to the 4 variable K map. So coming to the 4 variable, okay, coming to the 4 variable K map, 2 to the power of 4. 4 variable we are writing, right? 2 to the power of 4, that is 16. So we are going to write the 16 cell map. So we are going to start with 0, 1, 2, 3, 4, 5, 6, 7. Please note down the numbering here: 8, 9, 10, 11. So if you go wrong in putting the numbers properly, you cannot solve the problem properly. You should remember the numbering. In some textbooks, they have followed, see, if you have taken WX here and YZ here, they might have taken YZ here and WX here. Then the numbering changes. The numbering of cell changes. Don't think that they have given wrong in textbooks or our faculty has done wrong in classes. No. Once you change the position of WX and YZ, if you interchange them, the cell numbering changes. So better to practice only one way of representing the cell numbers. Okay, both are correct. So next, steps to solve K-maps. This is given here. We are going to give the slide to you later. You can see. I hope all of you know how to solve K-maps. You have to group min terms if it is a SOP map, and if you have to group max terms if it is a pause map, right? You can see that if you can make a pair, you can make a quad, you can make a octet. So That is how we are going to form groups. That is, we can make a pair, you can make a quad. Pair is nothing but group of 2 mean terms or max terms, and quad is nothing but group of 4 mean terms or max terms. Octet is nothing but group of 8 mean terms or max terms, right? So you have to see that whether you can form an octet first. So you have to go in this order. You have to check whether you can form an octet. If octet is not possible, you have to go for a quad. If quad is not possible, you have to go for a pair. If pair is not possible, what would you do? You will be left with a single mean term. You will be left with a single mean term. Okay. So why are we forming all these groupings? The groupings reduce the size of the circuit, or I can say it reduces the levels in the circuit. You will get a compact circuit, a lesser problematic circuit. Okay, so you should follow this way. First, you have to check whether you can form octet, then quad, then pair. Okay, then. See, many of you make such mistakes, so please be careful while grouping in K-maps. Okay, these are the common mistakes what you do in K-maps. What's the first mistake? See, you are grouping 0 and 1. It is not possible. You cannot group 0 and 1. Next, here, what is that? The mistake you have done here. Diagonally, you are making a pair. 1 and 1, diagonally you are making a pair. Even that is wrong. You cannot make a pair like that. Diagonally you cannot make. Okay, you cannot make a pair with 0, 1. These are the common mistakes. Those who have not at all attended the classes, these are the common mistakes they can do because they don't know how to form groups, right? And this is correct. See, 1, 1, you can form a pair. And even this is correct. Even though this one is common for this pair and this pair, the pairs are different. So you can include 1 here. Getting my point? Okay. So don't do such mistakes. And see here, you cannot form a group of 3 ones. You cannot form a group of 3 ones. Okay. And you can form group of 2 ones. That is a pair, group of 2 ones. Here you can form a group of 4 ones. That is quad. Okay. And again, this is wrong. Why it is wrong? Those who know very well about K-maps, see, you cannot form a quad, octet like this. You cannot form octet like this. Okay. So next, coming to the examples. So let us start with some simple examples. So those who have already solved such problems, it is easy for you, and those who are new to such problems will solve the problem. Okay. So here, simplify the 2 variable Boolean equation by using K-map. So that is f is equal to xy dash x dash y plus x dash y dash. Okay. So take this function and try to solve. I'll give you a few minutes of time. Just try to solve. Any doubts in this? Okay. Done, ma'am. Okay, good. Good. So those who have solved this problem, try to solve this problem with the truth table and K-map. So what is the solution you got? All of you got the same solution. F is equal to X bar, Y bar. How did you get this? So you have to form a pair. So when you form a pair, you should be able to directly tell the answers. You should be able to directly tell the answers and see how you should tell the answer directly. I'll tell you. In this place, you have to put 0. So how are you going to put? See, 0, 0. This is 0th place, first place, second place, third place. This is how you are going to number the cells. Those who have not understood this, I'm telling this. So here in 0th place, what is there? This is 0, right? Again, you have to take 2 to the power of 0, 2 to the power of 1. This is 0th place. Okay. 0th place, it is 0. So you should mark 0. This is done. And coming to the first place, in the first place, 1 is there. So put 1. In this place, 1 is there. Put 1. And in this place, 1 is there. Put 1. So first you have to see what you can form out of this. You can form a quad out of this. Can you? No, you cannot form a quad out of this. Then you have to go for pairs. Now check whether you can form a pair. I can form 2 pairs. So this is first pair and this is second pair. Right? So here, this is the first pair and this is the second pair. So now you have to directly write the answer. Directly write the answer. So this is X bar and this is Y bar. So what is common here for this pair? This is X bar. What is common here for this pair? This is Y bar. So you can directly write the answer in the SOP form. Someone has doubt in this? Ma'am, how is the truth table constructed? So that is the doubt. Yeah, I'm explaining. I hope Syed Shabazz got the answer for this K-map. Okay, and how to construct this, right? See here, X, okay, if you just write X, it is considered as 1 in SOP, okay? And if you write X dash, it is considered as 0, right? So here it is X is 1, 0, 1, 0 combination is here, 1, 0 combination is here. So since it is there, mark it as 1. Are you getting? Next, what is there here? X dash is 0, Y is 1. It is 0, 1. Since 0, 1 is present, if it is present, you have to just see the presence of that particular value. Okay. Since it is present, so mark it as 1. So function is marked as 1. So what is the next combination? It is 0, 0, right? Both are 0, 0. So if it is 0, 0, actually this one, if it is complement, if it is 0, 0, then it should be marked 1. Okay. So this should be marked 1 and here it should be marked 0. Right. So then now I will write the K-map like this. So if I write the K map here, it is 0, 1, 2, 3. So how are you going to fill that? 0 place it is there, 1 place 1, then 2, then 3 it is 0. So now if I write x, y here, so this is x bar, x, y bar, y. So here I'll consider this has one pair and this has another pair. Okay. So what is the answer for this? So the answer is x bar plus y bar. So actually here it is not given properly. So this is how you need to do. So then also you will get x bar, y bar as the answer. Okay. You got your doubts cleared? Okay. Suppose it is wrongly printed here. So suppose if I had taken like this, f of x, y, z, that is equal to sigma m 0, 1, 4, 5. Can you solve this now with truth table? With truth table and K-map, both. With truth table and K-map, use your book and pencils. Now try to solve. Are you able to do it? What is the answer? Okay. So many of you are trying it. Many of you are attending for the first time. It might be a little tough for you, but try to follow the methods. Problem. Are you able to see the screen? Whiteboard? Are you able to see the screen? Please. Okay. We will solve the problem in the whiteboard. So the question is, f of x, y, z, that is equal to sigma m 0, 1, 4, 5. This is the question. So according to question, in the function, how many variables are there? How many variables are there? 3 variables are there. So you have to write the truth table for 3 variables. So I will write the truth table here because this question is asked to solve with the truth table and K-map. You have to solve with truth table. You have to solve with truth table and K-map, both. Okay. So you start giving different combinations. See, many of you write the truth table in a wrong way. You first fill all the values for X, then you fill all the values for Y, then you fill all the values for Z. That is not the correct way of writing the truth table. Methodically, you have to write, say, if you take like this, so methodically you have to write that is 0, 0, 0. Next is 0, 0, 1. 0, 1, 0. Next 0, 1, 1. Then 1, 0, 0. Then 1, 0, 1. Then 1, 1, 0. Then it is 1, 1, 1. So this is how you need to write the truth table, right? So now you have base 2 with power 0, 2 to the power of 0, 2 to the power of 1 and 2 to the power of 2. This represents what? Decimal number 0. This represents decimal number 1. This represents 2. If I continue like this, the last one represents what? Decimal number 2 to the power of 2 is 4. 4 plus 2 is 6. 6 plus 1 is 8. So it represents that is 4, 5, 6, 7. You have to add like this. So it represents 7. 2 to the power of 2 is 4. 4 plus 2 is 6. 6 plus 1, 2 to the power of 0 is 1, right? So it is 7. Okay. So now you just see the function column. In function column, it is 1 here and 1 here. Then other things, say this is 3 is not there, 0 is there, 1 is there, 3 is not there, so put 0, 4 is there. The next number, it is also not there, then this is there, right? And 5 is there, this is 3, right? 3 is not there, it is not there. Can you see here? No, 3 is not there in this. So put 0 here, then 4 is there, so put 1, then 5 is there, so put 1. Okay, then others are not there, put 0. This is how you need to represent with the truth table. I hope you are understanding. So which are the minterms that are present in sigma m? That has to be put 1 and see that it is sigma m. Okay, it is sigma m, not pi m. So you have to put ones wherever the set of values are given. So now coming to the map, what type of K-map you need to put? Is it 2 variable K-map or 3 variable K-map? You need to put 3 variable K-map, right? So 3 variable K-map is represented like this, right? How many cells it has? Since it is 3 variable K-map, 2 to the power of 3. So that is 8 cells, okay? 3 represents the number of variables. So you're going to write like this. So it is 0, 1, 2, 3, 4, 5, 6, 7. This is the way of writing the K-map. And here I am taking the variable X and here I am taking the variables Y and Z. Okay. So this position is 0 and this position is 1. Okay. And this position is 0, 0, 0, 1, 1, 0, 1, 1. Okay. I hope you are getting this. This is how you need to represent things, the numbers here. And here you have to give X bar because it is min terms, right? Whenever 0 is there, in the previous slide I showed you, you have to put a complement. So here it is X and here it is Y bar
Z bar, Y bar, Z, YZ, YZ bar, right? So now keep filling the cells. 0 is there, yes, put 0 is there, put 1, you have to put 1. 1 is there, put 1. 3 is there, no, 3 is not there, so put 0. Is 2 is here, no, so put 0. Is 4 is there, yes, put 1. Is 5 is there, yes, put 1. 6 is not there, put 0. 7 is not there, so put 0. I hope all of you understood how to fill this K-map, right? Then see that what you can form out of this. Can you form octet? No, octet is not possible. Octet is group of 8 ones. Then we shall see that whether we can form a quad. Is quad possible? Yes, a quad is possible. A quad is possible. So now directly you need to tell the answer. You should not use any Boolean algebraic laws to solve this, because the purpose of K-map is to directly tell the answer without using Boolean algebraic methods. Don't use Boolean algebraic laws here to solve the K-maps. If you do like that, you will lose the marks completely, because the examiner will come to know that you don't know how to get the answer from K-maps. So directly you should be able to tell the answer. And how can you tell the answer directly? Just see the cells that are covered by this quad. It covers 0, 1, 4, 5, right? So the answer can be written as, see, what is common for the cells 0 and 1? Which literal is common for the cells 0 and 1? The cells 0 and 1, Y bar is common, right? Because Z bar plus Z, it will become 1. Into here X bar plus 1, X bar plus, that is OR operation, plus X, that is 0 or 1, it is 1, right? 0 or 1 is 1. So here we are left with Y bar. See, this Y bar is common, right? Z bar dot Z plus Z, it will become 1, okay? And here X bar plus X, that is 0 or 1. 0 or 1 is 1 only, right? So we will be left with Y bar, okay? I hope, so those who have attended the classes sincerely, it is easy for them to do such problems. It is like revision for them, and those who have not attended, they're attending it for first time, they can learn. But sorry, I cannot solve many problems here. We are going to give at the end many problems on such topics you can solve. So those who are attending it for first time, I'm considering both the set of students, those who are attending it for first time and those who have already attended. So in the medium phase, I'm going, okay? So this is the solution. I hope many of you got this answer. Yes? Okay. So, can you solve one more problem only using K-maps? I don't want truth table now. Solve it only using K-maps. F of X, Y, Z, that is equal to, okay, sigma M, 0, 1, 4, 5, 2, 3, 6. Come on, solve this. So how many variable map you need to put? First, you have to check this part. How many variable map you need to put? So based on that, you have to proceed. Yeah, I will give you a few minutes. Please solve this and let me know the answer. Put your answer in the chat box if you get the answer. Let me know how many quads are possible, how many pairs are possible. Two quads and one pair, Preetham Sharma has told, and one quad, one pair, two quad and one pair. See, I will give you a hint. Our aim, our goal is to get a very compact circuit. We don't want a bigger circuit. So how many quads you are going to get? 3 quads. The answer is 3 quads. Please check in your books. You can form 3 quads. So let me solve this. So since it is 3 variable, I have to write like this, 8 cell map, that is 0, 1, 2, 3, 4, 5, 6, 7. So this side I'm taking X and this side I'm taking Y. So let us fill the cells here. It is 0 and 1, then 2. So which are the cells that are 2 is there, 3 is there, then 5 is there, 4 is there, then 6 is also there. So other numbers are not there, right? So how can I do now? I can form a 1 quad here like this. I can form a quad like this, 1 quad. See, we cannot form an octet here. We cannot form group of 8 ones. That is not possible. So we should go to the next level, that is group of 4 quads. Group of quads we can see. So this is the next second quad. Then, yeah, many of you don't know the concept called map rolling. Map rolling. You have to use the concept of map rolling. Suppose I roll this, you consider this as a sheet of paper. On that I have written this. Suppose I roll this, it forms a cylinder. Suppose I roll this, it forms a cylinder kind like this, and this end meets this end, right? Then these 2 cells become neighbors. They are adjacent cells. That is 0 will be adjacent to 2 and 4 will be adjacent to 6. Right? They become adjacent? Yes or no? They become adjacent. So I can form a quad considering the map rolling concept. I can form a quad like this. So it is a very important concept in digital electronics while solving K-maps. We use map rolling. That is, we roll the K-map so that the cells 0, 4, 2, 6, they become adjacent to each other. Then you can form a quad. Now, I hope many of you understood why we got 3 quads. Yes? Okay. So now we need to what? Get the expression. So this is again 0, 1, and this is 0, 0, 0, 1, and then 1, 0, 1, 1, right? So this is obviously x bar, x, and this is y bar, z bar, y bar, z, y, z, y, z bar. Remember this concept, map rolling. Okay. So now, can you tell me the answer? So what is the answer for the first quad? What is common? Directly you should be able to tell. What is the answer for the first quad? This one. This is the first quad. It is x bar, because here everything, if you use Boolean laws here, you have to do these calculations mentally. Don't put it on paper. So y bar plus y, it becomes 1. Z bar plus z, it becomes 1. 1 into 1 is 1. At the top you will get 1. 1 into x bar is x bar. So directly you should be able to tell the answers. At the top, everything becomes 1. Okay, 1 into x bar is x bar. So now coming to the second quad. This is the second quad. So you can tell the answer. What is common? Here x bar plus x, it becomes 1. And what is common here? In y-axis, what is common here? Y bar. So I'll write, it is in sum of products. I should put plus sum of products. It is sum. So plus. So it is y bar. And coming to the map rolling concept, what is the answer here? What's the answer? What is common? Z bar is common. So the answer is x bar plus y bar plus z bar. How many of you have got the answer? If you have got the answer, it is good. If you have gone wrong in making groups, then please try to change the way you make the groups. Okay. So first, always you have to see that you can form an octet. If octet is not possible, go ahead and try to form a quad. If quad is not possible, then you have to go for a pair. If pair is not possible, then only you have to take single term. And for this equation, you need to obtain the circuit diagram. How are you going to obtain the circuit diagram for this equation? So usually they'll ask you to write the function and write the circuit diagram. So I'll write one circuit diagram as an example. So I'll take x, y, z. So this is x line and this is y line and this is z line. We need x bar. So I'm using an inverter here. I'm using an inverter here. So what is that we want here? We want this equation. So that is x bar, then y bar. Okay. I'm using a OR gate over here and then z bar. So I'm using one more OR gate. So this is the function. So this is how you need to write the circuit diagram. Usually they'll ask you to write the K-maps and circuit diagram, or else they can ask you to write the truth table with K-map and circuit diagram. So read the question properly. Okay, I hope you are understanding these concepts. And you can try this later, not now, because time is not there so much to solve many problems over this. You try to solve this, you just take down f of a comma b, that is equal to a bar b plus ab bar. Okay, solve this. Then f of a comma b comma c, that is equal to a bar bc plus abc bar plus abc. Okay, so try to solve these problems. Okay, yeah. Shall we go back to the slides? Okay. So this is how we need to do. This is one more problem. F of A comma B comma C, that is equal to sigma M 1367. Try to solve this. I'll give you a few minutes of time. Try to solve this. Try to solve this. Okay, I guess many of you are done with this. We shall go to the next one. So you can see that it is a 4-variable K-map. In 4-variable K-map, we need 16 cells, and the cell numbering also it is done like this. You can observe that 0, 1, 2, 3, 4, 5, 6, 7, right? And just try to solve this problem, f of PQRS, that is equal to sigma M 02578. You have to just fill the values that are required. And here also you can observe that they are using map rolling concept, right? So when you roll the map, these corners, they come together, right? So the 0 cell, 2nd cell, 8th cell, 10th cell, they become adjacent, right? So here also we are making use of map rolling concept. So finally you are going to get this expression, and for this expression you have to write the circuit diagram. You are very much familiar with the circuit diagram. And those who want to solve one more problem on this, you can solve this problem if you want. And let me know the answer. I'll give you a problem. F of A, B, C, D, that is equal to sigma M 0, 1, 4, 6, 9, 8, 13, 14. Those who have solved this, they can try this. ಚಾಟ್ ಅಲ್ಲಿ ಬರೋದು ಹೇಳ್ತಾ ಇರ್ತೀರಾ ಏನಾದ್ರು ಬಂದ್ರೆ ಏನಾದ್ರು ಹೇಳಿದ್ರೆ ಇಲ್ಲ ಇಲ್ಲ ಹೇಳಿ ಏನಿಲ್ಲ ಅಲ್ವಾ ಒಂದು ಬಂತದ್ದು Are you able to solve this? The new problem, whatever I have given, f of a comma b comma c comma d, it is the number of variables shows the type of K-map. So you should use a 4 variable K-map. So sigma m 0, 1, 4, 6. So you have to write it. If you have got the answer, please share in the chat box. Okay, you can try it later. As there is short of time, I cannot wait for the answers. If you have got the answer, you can reply. But you know the method how to solve it since it is revision. And coming to this, you can observe here, we are using pi m. Can you observe that? Max terms. So max terms, if you are using, you have to be careful. See, what are the values that are mentioned here? What are the values that are mentioned here? That is pi m 0367. This you should observe, right? If you go wrong in this, if you answer it thinking that it is sigma m, your complete answer is wrong. They will not give you any marks for that because they think that you don't know how to represent it with K-map. Okay, don't expect any marks for that. Okay, so you have to use pi m 0367 function. For this function, you have to put zeros wherever the terms are present. Okay, not once because it is pi of m. So see, in 0th place it is there. So put 0, 3 put 0, then 7 put 0, 6 put 0. Now try to form groups as you formed for sigma m. It is same. Okay. So now you can form a pair here and you can form a single terms. No other groups can be formed here. So now you can be able to tell the answer directly. So what is the answer for this? What is the answer for this? And what is the answer for this? So let us take this pair first. If we take the pair first, so here, if it was sigma m, we would have written BC, right? But here it is pi m, so it will become B bar, C bar. Reverse you need to take, completely opposite. And we used AND operation there, but here we need to use plus. Okay, so that you have to remember a lot. I'll explain this once again. Okay, see, in pi m function, you have to be very careful. When you're forming a group, you form a group. It is the same way how you did for sigma m. After forming the group, you have to mention the answer, right? So first we shall take this pair. This pair, see here, what happened before? It is B bar, C bar. Before in sigma m, B bar, C, B, C, B, C bar, right? It was like this. But when we are working on pi m, it is the reverse you need to take, that is B plus C, B plus C bar, B bar plus C bar, then B bar plus C. So this is what you need to take when you are working on pi m functions. Okay. So obviously the answer for this is B bar plus C bar. Okay. Naveen R as asked, we can do pair with 6 and 7, right, ma'am? 1 second. 6 and 7. Yeah, you can form a pair in that. It is nothing wrong in that. You can form a pair. Okay, good. You have come out with that. It is correct. But the thing is, who is that? Naveen, right? So whatever you have told is correct. You can form a pair with 6 and 7. Okay, I will form a pair here. You just observe. I will form a pair here with 6 and 7. Okay. What happens here? 6 is without considering 6 as a single term, you can do it. Otherwise, if you have already considered 6 as a single term, you cannot do it, because the 0 present here, it belongs to this, and 0 present here, it is taken as single. Yes, you can do it. It is also correct. It is one way of representing. It is correct. Okay. So this one, I hope all of you understood how you got B dash plus C dash. You got this. Okay. Then if you are taking them as single terms without forming pair. So what is the answer for that? What is the answer for this? It is, this will be what? A, and this will be B. So this one will be A plus B plus C, right? So you got both. Suppose you want to form a pair over here, you will get a different answer. Suppose a pair is not formed, a single term is taken. So what is the answer we are left with? We'll be left with this one. We'll be left with B bar, then plus C. Sorry, this is A. Okay. Then what? A bar. So we'll be left with A bar plus B bar plus C. Okay. Suppose you form a pair. Suppose you form a pair out of this, right? So what would be the answer? What's the answer? Suppose you form a pair. What is common for this? What is common for this? It is A bar. And what is common for this? These two. It is what? B bar. Right? So you are going to get the answer like this. So this is one way of doing it. So please understand how to solve this see, how we are forming pairs or groups, it is important, right? Try to solve with more number of quads, pairs, octets, right? So try to solve with that. Okay. So next. So this is one more representation. So f of a, b, c, d, that is equal to pi of 3, 5, 7, 8, 10, 12, 13. So please try to solve this. I'll give you a few minutes of time. See that here we have taken pi. Sometimes in question paper, they just mention pi. Okay, it is understood that it is pi m. Okay, so don't think that it's a different function. It is pi m. So try to solve this. I'll give you a few minutes of time. We try to solve this. You have to try to solve it orally. If you have any doubts in getting the expression, you can ask in the chat box. Here we are getting the answer in the form of pos. Here we are getting the answer in the form of pos because we have pi m there. It is exactly the reverse way of what you do in SOP. Okay. I hope you got the answer. Yes, shall I go ahead? Check again. Okay. Can I go ahead? All of you got the answer? Yes, Ayush is doing good. Ayush, you are trying. If you are finding it difficult in some part, you can ask. Answer is already given. Okay. So this is how I'm just taking some sample problems and I'm giving it to you. I cannot solve many number of problems since it is a webinar and I cannot complete all the problems. I'm just giving the sample problems for you. Okay, so I'll go ahead. So next, coming to don't care conditions. All of you are familiar with the don't care conditions, right? But you don't know how to use these don't care conditions. If don't care conditions are present, you think that you can use them. No, it is not that if they are present, you should use them. Okay? So don't care conditions are represented by the letter X. Okay? So this X is considered as 1 for min terms. So when we are using min terms, we consider it as 1. And X is considered as 0 for max terms. Okay. So when we are using sigma m, we are using it as 1. We are using pi m, we are using it as 0. So don't care conditions are used for grouping min terms and max terms. See, this is just a simple example. You're already familiar with using don't cares. I've given various examples how don't cares are used. You can just observe the first one. In the first example, you have got a problem where you have filled, where you have already filled, once. Okay, this in the 0th place, 1st place, 2nd place, 3rd place are given. You have already filled once. You are in the mid of the problem solving part. Here two don't cares are present, that is 0, 1, 2, 3, 4, 5, 6, 7, right? So don't cares, it is mentioned like this. For this problem, they might mention f of a comma b comma c, that is equal to sigma m. Okay, the ones are present in 1, 2, 3, 4, 5, plus it is represented with don't cares. Okay, which are the don't care? Sigma don't care 6, 7. So this would be the question for this. Okay, so this question is already given and you are in the mid of solving the question. So you will get a map like this. Now, how to group? How to group? So how to group? You have to see that you have to move from higher hierarchy to lower hierarchy. So quad, is it possible? Octet is not at all possible. Quad, it is possible. Yes. How many quads can be done with this don't cares? Using this don't cares, I can form 3 quads. Suppose I don't use this don't care. Okay. I will be left with a pair. Okay. So I'll just show you a simple example for two variable f of a comma b, that is equal to sigma m 0 comma 1 plus don't care 2. Okay. So how will you fill this K map? It's a two variable map. I'm going to fill like this. That is 0, 1, 2, 3. So which are the variables given? In 0th place 1, 1 place 1. Don't care. Here I have to put, and here I have to put 0. Right? I hope you are getting this. So this is A and this is B. So this is 0, 1, 0, 1. Right. Now, don't care is present. I should consider the don't care or not? We have to think. I can form a pair here. Right. So what is the answer for that pair? So F will become A bar. Right. F is A bar. Suppose I take this pair also, 1 and don't care. So what will you get the answer as? A bar, it is sum of products, right? A bar plus B bar. So is this circuit complicated or this circuit complicated? The second circuit is complicated because you have more number of wires here. Whereas the first circuit is not less complicated compared to the second one. So what I want to tell you is unnecessarily don't use don't cares. Here you need not use don't care. Leave it as it is. You are fine with this. Whenever required, then only you need to form. Suppose I give one more function f of AB, that is equal to sigma m 0, 1, okay, plus don't care 2 and 3. Okay, so what will you get? You will be filled with ones in all the cells. So when you are filled with ones in all the cells, you will get a quad, right? So quad is nothing but 1, because when you simplify it mentally all the values. Okay, so here A bar A 1 into B bar B 1. So only one line, right? So you have to think properly. You have to use your common sense whether to take don't care or not. Okay, see the second example, they are taking it, so you can get 2 quads. Here also they are taking it, you will get 1 quad and 1 pair. Here you are here also they are taking them, because if you use the quad, you will get the answer as A. Right, this answer as A. If you don't use this, say if you don't use this, what will you get the answer? F is equal to A into B bar. So which is the lengthier circuit? This one. So don't do this. So take this for quad. So you have to check that. You should not get the lengthier ones. Okay. Here also you can form a pair. Don't go for grouping 3 like this. I've already shown do's and don'ts, right, in maps. So I hope you understood this concept. Shall we go on to the next concept? Okay. So here also you can observe they have used don't cares for 4 variable map. Okay. So try to solve this. I'll give you a few minutes. For 4 variable maps they have used don't cares. Please solve this. Can we group 5 and 7? G1 is asking in the previous slide, right? I'll just check. Before beta. Can we group 5 and 7? G1, your question is, can we group 5 and 7? In this part, you cannot group 5 and 7 because the maximum 0 that is present in cell 5 is already included in 13. Once it is already included in some pair, don't include it again. Suppose, see, it is no rule that all of you should form the pairs in the same way. You can also form pairs like this. You can form, you can form pairs like this also. Even this is possible. right? So, but use your common sense so that you will get minimum number of terms here. Okay. See, if I form a pair 5, 7, it becomes redundant. This becomes a redundant pair, a repeating pair. It is called redundant in digital world. So don't have redundant terms. If redundant terms are there, your circuit becomes bigger. Our aim or goal is to get the compact circuit with more efficiency, right? Getting the point, Naveen? Okay, I gave you a problem in this. I hope you are able to solve that using don't care, this one. Just try to solve this. Or you take down the question and try to solve it later. Yes, Naveen, because it is redundant group, we should not pair. Because your circuit becomes more lengthier. It becomes more lengthy. It becomes bigger. You should avoid redundant pairs. If one term is included in one pair and another term is already included in another pair, you cannot group those two. Okay, I hope all of you got this. So here you are getting 2 quads, 1 pair, 1 term. Single term. This term cannot be grouped with any of this. So you are getting 2 quads. This is 1 quad. And this is the second quad, map rolling method. And this is a pair. Okay, this is a pair. And this is a single term. Okay, you can try this, you can copy down the question and the answer also you can note down and later you can try. So next, coming to the next one, that is this also the question you can take down. This is using max terms. Using max terms with the don't cares, please take down this question and try to get this answer. Sahar Jan, octet. Sahar, are you asking the question for this problem? Can you form an octet? How can you form an octet? Previous. Where can you form a group of 8 ones? This one? Is this the question? Adena. Sahar, tell me where you can form a group of 8 ones. Continuously it should be there. The ones should be in the adjacent cells, continuous cells. They are not there like that. They should be adjacent, immediate adjacent. So you cannot form. It cannot be. You cannot do it. Understood? Okay. Coming to this, here also you cannot form octet. Hope you are getting the point. So you can form a quad. Okay. So please take down the question, try to solve it because we have limited time. So next, I'll hand over to Professor Jaishubha Madam. She will continue with MEV method. Okay. For that, we will take some 10 minutes break. Please, all of you come back by 12:10. Okay. So MEV method in K-maps, it's very important. It has been asked many times in exam. So she will start with MEV method for K-map. So kindly come back by 12:10. Until now, whatever I have covered, they are very important in examination point of view. All such problems with the different values, with the different functions will appear. Now at least we have covered some 20 marks out of this K-maps. Okay, So please come back by 12:10. Okay, thank you. Okay. So till 1 o'clock, we are going to conduct this session. After that, we are going to give lunch break. 1 to 1:45 is lunch break. Then the afternoon session starts with Quine-McCluskey method, which is a very, very important method. In every exam till now, how many exams have happened, right? Till now, in every exam, they have given that Quine-McCluskey method, also called tabular method. It is very, very important, and usually they ask that question for uh, 12 marks, 15 marks also, many times they've asked. So if you answer that properly, you will easily get 15 to 12 to 15 marks in that only. It is not tough, but it is a little lengthy. It is little lengthy. But if you start solving that problem in a proper way, in a systematic way, and neatness is required while writing the answer in analog and digital electronics, so that will not go wrong. So you have to maintain neatness while answering. So McCluskey method is very important, which we are going to do in the afternoon. Quine-McCluskey method, also called tabular method, also includes Patrix method in that. Okay, so even that is important. And we are going to discuss the previous year question papers and question bank, how to answer the previous year question papers. All those things we are going to discuss. So please don't miss the afternoon session also. So kindly come back by 1:45 itself, so that we can finish it off fast. Illana.
Yeah. Good afternoon. Am I audible? Good afternoon, all. Okay, so now we'll start with the MEV method, that is map entered variable of solving a SOP equation, right? Have you all returned? Just put in the chat box whether I'm audible or not. Okay, assuming that I'm audible. Yeah, before going to MEV, I will just have a small recap of the K-map rules. So in the K-map, when you're forming the groups, you have to follow these rules, whatever is given here. So first, in a K-map, after doing the entries according to the output, you have to first search for an octet. If at all you are not able to find an octet, then search for a quad. Then if a quad is not available, then search for a pair. Even if a pair is not available, then you can have a single term as a group. This is because our aim is to get the simplest equation to form the simplest circle. Hence, we have to always go from the largest group that can be formed. So if you follow this sequence, so you will not be missing the largest group that is available, right? So after that, after forming groups or while forming groups, you have to consider the overlapping groups. So overlapping groups are those in which maybe apart from one element of the group, even if all the other elements are present in other groups, you can consider that as a overlapping group. And next is rolling of maps. So rolling of maps, to form groups using the corners and edges, we use the rolling of maps. Already it is explained in the first session. So just a recap of that. And next, to eliminate the redundant groups. So redundant groups are those in which a group in which all the elements are formed parts of other groups. So if all the elements of a particular group are parts of other groups, then that group is a redundant group. So such groups should be eliminated. So these rules are valid even for MEV method. So here you have the MEV method. So in the MEV method, as the name suggests, so we have the variables, right? In the variables, one of the variable will be entered as a K-map entry. It will be entered inside the K-map. That is, output is compared with the variable and it is entered inside the K-map. So why we do this is, this reduces the K-map size by 1 degree. So that is, if a 3 variable problem requires 2 power 3, that is 8 locations in the K-map, if we use MEV method, it will need only 2 power 3 minus 1, right? Because it is reducing by 1 degree. 3 minus 1, which is 2 power 2, so it results to 4 locations. So instead of 8 locations, you'll be needing 4 locations if you use the entered variable map. So this is the main advantage of using a entered variable map, and it is mainly useful for more than 4 input variables. Wherever you have more than 4 input variables, in such cases, you'll be using MEV method. Otherwise, you may need, for a 4 variable itself, you need 16 cells K-map. But if it is more than 4, you can imagine what is the size of the K-map. Hence, to avoid that, we use MEV method for more than 4 input variables. So this is the rules that has to be followed after entering the value in the K-map. So this I'll come back. We'll just go for the previous, that is how to enter the K-map. So this is a truth table, a problem given here. So this is not in the form of the canonical equation. This is in the form of standard SOP expression, right? So here this has to be now converted into canonical form, and then it has to be converted into the truth table. Can you write the truth table using only this equation? Can you write the truth table using this equation directly? Is my screen visible? Can you see the truth table? Okay. So we cannot write, right? So how to first convert this equation into canonical form? So that is shown here. So in this, after expand, so first to convert this equation, we have to expand it, right? We have to expand the equation. Like in the first term here, we can see a dash, b dash, c. The variable d is missing here. So for canonical, we need all the variables. So for that, we have to expand. So now this, I'll write it as a dash, b dash, c into d plus d bar. So the value of this minterm will not change, but we'll get the term d. So this has to be written as, just a moment. Yeah, so for the first term here, for this term, I'll change the color, just a moment. Yeah, for the first term here, okay, you can observe this, right? For this term, the variable d is missing. So for that, you have to write it down as d dash, b dash, c into d plus d dash plus d, right? So after writing this, now we have to expand it. So if you expand it, it will be a dash, b dash, c, d dash. So this is the first term after expanding, and this is the second term after expanding. So if one term is expanded, you'll get two terms, right? So you get a dash, b dash, c dash, d dash plus a dash, b dash, c dash, d. This is for the first term. Similarly, if the second term is expanded, we get it as, so here you have the second term, that is a dash, b, c. So that is expanded as a dash, b, c, c dash, d dash plus a dash, b, c, d, right? Similarly, you have to do for whichever variable have only three literals, whichever midterm has only three literals, all those terms have to be expanded. So third and fourth are fine. So fifth term has to be expanded. And after it is expanded, you'll get it as a b dash, a c, d dash plus a b dash, c, d. So this is the equation. So from this equation, you can convert it into the canonical form. So for conversion, I'll just show how to convert it. A dash, value of a dash is, in binary you have to write it now. A dash will be written as 0, b dash is a 0, c dash is also a 0, d dash is also 0. Hence the decimal of this is 0. So you got 0 in the canonical equation. And then this is again 0, 0, 0, 1. So binary for 0, 0, 0, 1 is 1. So you got the minterm as 1. So like this, now you have to write the binary for each literal present in the equation. Then take their decimal values to write the equation in canonical form. Did you all understand this? Any doubt here? Because you'll get the questions in this form also. It cannot be always in the form of canonical equations, right? So if you get it in this form, which has an equation which has only three variables, then you have to expand it, then write this equation, then form the canonical equation. So this is here in the equation. Here it is inside the bracket, and this is nothing but don't care. Hence, here you have it as sum of don't cares 10, 11. Right? So this is 10 and 11. So now after getting this has to be entered in the truth table for the MEV method. So this can be for the K-map or MEV method, or even QM method can be asked with this form of the question. So after that, now we'll go for the truth table. So this is your output. So this has to be filled, this column has to be filled using these canonical values. So for 0, 1, 6, 7, 15, you have to fill it as 1, 0, 1, 6, 7, and 15. So 15, I think you're not able to see here. Just a moment, if I can make it visible. Yeah. Hope you can see it now. So at 15, you can see that the entry is for the output is 1, right? Then you have to enter don't cares. So don't cares, you can see that it is 10 and 11. So here for 10 and 11, enter them as X, because don't cares have to be entered as X. And then remaining values, fill it up with zeros. All the other values, fill it with zeros. Right? Understood how to write the truth table? Now, coming to the MEV. So here, YD. So what does YD represent? What is D? So D tells that the variable which has to be entered inside the map is D. This D is nothing but the variable which is entered inside the map. You can either enter any of the variables, but we usually go for D because the simplification will be easier. So when you enter D, the other variable should be of the same value. That is the main concept here. When you're going to take D as the entered variable, the other values have to be constant. Only that particular variable should be changing. So with that concept, when we take D as the entered variable, the other constants will be, other variables will be adjacent, so that you can compare D with output and you can write the combined map entered value. So this is the map entered value. So how to write this? So to write this, you have to compare output. That is why you should compare with the map entered variable. D is the map entered variable. So compare Y with D. So when Y is 1, when D is 0, Y is 1. When D is 1 also, Y is 1. So irrespective of the value of D, Y is 1, right? Hence, here you'll write it as 1. Hence, this is written as 1. Similarly, coming to the next, when A, B, C is 0, 0, 1, D is changing and Y is 0, whether D is 0 or D is 1, Y is still 0. Hence, this can be written as 0, right? In the next also, A, B, C are constant. You can observe that A is 0, B is 1 and C is 0, whereas only D is changing, and even though D is changing, the output remains as 0, and the entry will be 0. In the next case, again, output is 1, whether D is 0 or 1, hence the entry will be 1. In the next it is 0, 0, so it is entered as, the map entered variable is entered as 0. So next, you can just write it down as X itself, or if you have written it as 1, then you can write it as 1, right? And then for the next entry, it is again 0. And for the last one, when you come for the last two entries, that is when A, B, C is 1, 1, 1. See, if D is 0, output is 0. If D is 1, output is 1. So here you can see that output is same as D. Hence you write the entry as D. The output is same as D. Hence it is written as, hence the entry is written as D. Understood? Suppose it was reverse. Suppose it was 1 here and 0 here. then you would have written it as D bar. Because when D is 0, output is 1. When D is 1, output is 0. So that will be written as D bar. So these are the only 4 entries that can be made in a MEV map, right? So we'll just look into the solution for this. So after writing this, now these values have to be entered in the K-map. And after entering in the K-map, now I'll just tell the rules, then go for this solution. Back. Yeah. So now we'll just see the rules for grouping, because in MEV method, there are quite a lot of confusions. So here the rules are, in the first one, after doing the entries into the K-map, first thing is group all ones with other ones or X. So all the bits which are entered as ones should be grouped with other ones or using don't cares. So this we anyway follow in the K-map also, right? So group ones with other ones or don't cares. Next, replace ones by don't cares. Replace all don't cares by ones. Replace all ones by don't cares. Then group only alike MEV terms. This is more important. Group only alike MEV terms, right? So here in the first one, you can see that only the entries have been made. And here, except for ones, all the other entries are made as 0. This is to avoid confusion, it is entered as zeros. But if you are comfortable forming a group in this only, directly you can form a group, right? If you are comfortable with directly doing it in this K-map only, you can do it in this K-map itself, right? Otherwise, if you feel you may get confused, except for ones, all the other entries, make them as zeros shown here. Make all the other entries as zeros as shown here. Then group only the ones. So in this example, only these 2 bits are ones, so it is forming a pattern, right? And after grouping, you have to write the equation. So for this it is C here, and here it is A dash. So the equation is A dash, right? Then, so after grouping ones, so next step is replace ones by don't cares. So ones have been replaced by don't cares as shown here. Now we have to group the like terms, because why we replace it don't cares is that if you had a D here, this can be grouped with a don't care. But here the D's are replaced as ones. Again, just to avoid confusion, the D's are replaced with ones because only D's. You can see here only D. You cannot group D and D bar, right? You have to group only like terms. So don't group D and D bar. So these entries where you have D is replaced as ones, and that is formed a group. So for this group, the equation will be A C dash, right? And then you are left out with D bar, right? So that D bar is replaced here as ones. Can you see here? And these are already replaced as don't cares. So ones can be always grouped with don't care. So just form it as a quad. Form that group as a quad. And hence for this quad, the equation will be C. Right? Understood? So this is the procedure for, and here, see, while writing this, see, of course, this is C dash, and here A is constant. But along with that, what is the value of this? This is not a 1. This was replaced for D. So here, we'll get the equation as A, C dash, D. And here, because these were not ones, these were replaced for D bars. So hence, this equation will be, the actual equation, it will be C D dash, right? So final equation will be CD dash for this, and this will be AC dash D. Because we are replacing the map entered variable as 1 here, while taking the equation, while writing the equation, we have to consider that variable. That variable has to be multiplied with the other terms, right? So these are the rules to be followed while solving a MEV problem. That too in a K-map. While grouping in the K-map, these are the rules to be followed. That is because we are reducing the map using the combination of entered variable. I'll go to the next slide. Just a moment. Next slide. Next. Hyperlink. Okay. So now we have seen how to write the truth table here, right? And for this, the simplified equation is given here. We'll see how it is solved and how we got this equation. Just a moment, I have given a hyperlink. It's going to the file. Yeah. So in this 2 rows by 4 columns, you can write the K-map either by 4 rows, 2 columns, or 2 rows, 4 columns for a 8 variable K-map, for a 3 variable K-map, right? So here, this is entered for YD. Whatever you have in the last column YD, whatever you have got the 8 entries from 16 entries, that has to be now entered. So here you have 1 is entered in the first place, then 0, then the next 0 in the last, then come back to the third one, 1. So it is 1, 0, 0, 1, then 0x, 0d. These are the entries. So same thing is here also. So now after doing the entries, you have to now form the groups and find the equation. So here 1 is formed as a group, then D can't be formed as an individual group, so D has to be grouped with the 1. Then this 1 is alone, so this also has to be grouped. In MEV method, you have to consider single groups also as a group, single ones also as a group, right? So now we'll take this as the first one. So for this, the min term will be for this first group, that is for 1, the single one, the min term will be A dash, B dash, C dash, plus for the second one in the first row, for that it will be A dash, B, C, you can see here, A dash, B, C. And then for the pair of 1 and D, it is B, C of course here, but here in the entry itself you have a D, so that also has to be considered, right? Hence it is, the equation results as B, C, D. So this is the final equation. This is the final equation, right? The simplified equation. If at all they have asked you to draw a circuit, you have to draw the circuit for this, where you need 3 AND gates and 1 OR gate. Where you need 3 AND gates for 3 some product terms and 1 OR gate for 1 sum term, right? So next, there is one more example here. No, that's it. So this is the only example. Yeah, this is a question. The equation is F is equal to summation of min term 0, 1, 6, 7, 15 plus summation of don't cares 10, 11. So somebody wanted to see the question, so I think you can see it now. Yeah, so understood this MEV method. So shall we take one random example and try? Ma'am, will they give maximum terms in the question in exam for module 2? Max terms. Yeah, you will get max terms also. There is no restriction that max terms should not be asked. You will get the questions for min terms as well as max terms. Min term means you'll be solving for SOP, and max terms means you'll be solving for POS. Because first module 2 contains both. So it will be given. Questions will be coming on max terms also. Okay. So we'll take some random example. Max terms for MEV method, they'll not ask. MEV method will be mostly on SOP only. Till now, in none of the question papers they have asked MEV method for max terms. It is only for min terms. So please repeat this again. Which one? Should I repeat the K-map? Whole example. Okay. So this is the example. 1 second. If I want to go to the slide again. So initially, we had to generate this. We have to calculate this canonical equation. We have to find out this canonical equation because the question was in SOP form. It was in a Boolean expression form. So wherever you didn't have the variables, just a minute. I'll try if I can go back to the slide. No, the slide over. Slide. Okay, so this was the equation, the Boolean expression. This was the Boolean expression where in some of the minterms, one variable was missing. So that had to be expanded. So for expansion, whichever variable is missing, you have to add that to the minterm. So for example, A dash B dash C. For this into D dash plus D. So you have to show that. I will show for one term now. So for this particular minterm, you have to expand it. So it can be expanded as A dash B dash C into D dash plus D, right? You have to write down like this. Then you have to take both the minterms. So you can see here, when I multiply A dash B dash C with D dash, this is the minterm. And when I multiply this with D, this will be the minterm, right? So like this, you have to do for other terms wherever you have one variable missing. So whichever variable is missing, that has to be written in this form and the equation has to be expanded. After expanding it, now you have to write the values for each of the variable in binary. So whenever it is complement, you have to write that value as 0, right? So here all the variables are complemented, so it is 0. All the 4 bits are 0. Here it is 0, 0, 0, 1 because D is not complemented. So similarly, write the binary for each of this. After writing the binary, now take their decimal numbers. So if all the bits are 0, 0, 0, the decimal number is 0. For 0, 0, 0, 1, the decimal number is 1. So like this, observe all the binary, then convert them into the decimal value and write the canonical equation. This is the canonical equation. So whatever is in the bracket here, this is nothing but the don't care term, right? Hence, that is also expanded and you get it as summation of D 10, 11. So after this, we'll get this truth table. After getting this truth table, so we saw the solution, right? After getting the truth table, I'll just show the K-map here only. You have to write the K-map for a 8 variable question. 8 cells. 2 power 3. You have 3 variables. So your K-map will be having 8 cells. So just draw the K-map. So here, this is, should I tell the cell values? No need, right? So this is 0. At 0, you have to write 1. So I'll write a 1 here. Then I'll take A here, B and C on the horizontal, A as vertical. So 1, 0, 0, 1. So the sequence is always first cell, second cell, then go to the fourth cell, then come back to third cell, right? Hope you all know the reason, because adjacent terms, in the adjacent terms, only one variable should be changing. So due to that, this change in the sequence is done. And next is 0, X, 0 in the last cell, then D in the third cell of the second. So after writing this, now we have to write the equation by grouping. So how will I group it now? I think yeah. So I could not see this previously. So here it is 0x, okay, 0 and D. It's fine. So now we have to do the grouping. So how will you do the groupings? First is, if you go to the according to the rules, you have to group all the ones. So once here I can just form a single bit. So I can form a group of a single one here. So form that group. Then again a single one here. Form this group, right? Then you are left out with a D. So no variables inside the MEV K-map should be left without grouping. So you have to group, and these variables can be grouped only with ones. Or if you have one more like term of D, you can group it. If you have two similar like the variables, you can group it, or it has to be grouped only with a one. So now considering this as the first group and this single one as the second group and this as the third group, the equation will be F equals, for the first group it is, here it is A dash, and here it is 0, 0, which is nothing but B dash, C dash. So for the first group, the minterm will be A dash, B dash, C dash. Then for the second single one group, it is A dash, B, C. Right? So you have to remember the column headings and the row headings. I have not written here. And next, for the pair of D and 1. Of course, this is BC, but we cannot write only BC because inside the K-map there is a variable. This also has to be multiplied. Hence it is BCD. Right? So this is the equation, the final equation. So for an example, let's try one random example. I don't have the solution for this because f is equal to ABCD, f of ABCD equals, so just assume that it is f of ABCD, summation of minterms 0, 2, 4, 5, 6, 7, 10, 11 plus D 8, 9. Yeah. So for this equation, try to solve. I'll just give 1 or 2 minutes. You can try to solve. So first thing is, what's the first step? You have to write the two table, compare output with the entered variable, then reduce it from 16 outputs to 8 outputs. Then those 8 outputs have to be entered into a K-map, right? Entered in the K-map, then the grouping has to be done. So I'll just go to the whiteboard. Close one. Share screen now. Whiteboard. I want that question also, right? I want to get the question now. What is share ಮಾಡಬೇಕಾಗುತ್ತೆ. Yeah. So can you all listen to me now? Am I audible? Okay. So here, first, I have to write down a question. So the question was f of a, b, c, d, which is equal to summation of min terms. If anybody can just type the question in the chat box. I think 0. Did I start it with 0 or 2? Just a moment. Can anyone share the question, or we'll just take a different one here? If it is different, don't worry. So I'll just take it as 2, 4, 5, 6, 7, 11, 12. So take this question, because that I cannot again go back. Don't care. 10, 11. Right? So consider this as the question. Okay. Now you have to write the truth table, because in MEV method without truth table you cannot reduce it. So you have to write for 0, 0, 0. It is 0. 0, 0, 0, 1 is also 0. 0, 0, 1, 0. Then 0, 0, 1, 1. 0, 1, 0, 0. 0, 1, 0. So write the values from 0 to 15 in binary. Then enter the output. So this is 9, 10, 11, 12. This is 0, 1, 1, 0, 1, 1. Then it is 1, 1, 0. Then it is 1, 1, 0, 1, 1, 1, 0. Then it is 15. Right? So for this, you have to enter the output. So for 4, it is 1. For 5 also it is 1. For 6 also it is 1. 7 it is a 1. 11 is a 1. 12 is a 1. Then 10 is a don't care. Okay. And this you just take it as, because 11 is present in both here. So this you take it as 14. So 14 is also don't care. Right? So remaining terms fill it with zeros. Right? Now we have to write the entered variable, MEV. You can either call it as MEV or you can call it as Y with the subscript of the variable. So again, I'll be considering D only as the map entered variable. So for this, you have to observe if it is same, you can just write it as 0. For the first two outputs, if the output is same, you can just write it as the output whatever it is. If it is 1, 1, you write it as 1. If it is 0, 0, write it as 0. Then for the next one. So if you observe here, if Y is 0, D is, if D is 0, Y is 1. If D is 1, Y is 0. It is opposite, right? Hence, output is opposite of D. Hence, we write it as D bar. And next, both are 1s. So the entered variable will also be 1. Similarly, for the next two entries also, both are 1s. Here again, both are zeros. And here, ten and 14, make it as 10 and 14 in the don't cares. And then when you are grouping 1 with a don't care, consider the don't care as 1. So I will write the entered value as 1. In the next group, you are grouping 1 with a 0. So just compare it with the D. So if you observe, if D is 0, output is 1. So it is nothing but D bar. And then here consider don't care as 0 because here you have a 0. When you are grouping 0, don't care with a 0, consider the don't care as 1. And when you are grouping don't care with a 1, consider don't care as a 1. Here we have considered don't care as 1, but here we have considered it as 0. Because here we are grouping x with 0, we'll consider x as 0. Here we are grouping x with 1, so we'll consider x as 1. Don't care can be considered as either x or 0. We all know that, right? Hence, here x is considered as 1 and here it is considered as 0. So now these values, you have to enter these values into the K-map, right? So now for the K-map, you have to take a 2/4 K-map. So here it is A bar A. So here it is B bar C bar, B bar C, BC, and this is BC bar, right? So for 0, 0, 0, the entry should be 0. Then for 0, 0, 1, this is 1. So it is D bar. Hope all of you are doing along with me. For this 1, 1, 0, 1, 1, it is 1. For 0, 1, 0 also it is 1. For 2 also it is 1. For 3 also it is 1. And next 0, 1, D bar in the last column and then 0 in the third. Did you all get this? Okay. Now after this you have to form the groups. So first thing in the rule was group all ones. So what I have to do, I have to group all the ones. So I'll just group this. So this also will form a group. Next, group all like terms. You have a D bar here and we have a D bar here. But these two cannot be grouped together. So what you have to do, you have to group this D bar with this one and group this D bar with this one. Please remember that these variables can be grouped with the same variable or it has to be grouped with one. Only D bar can't form a group. Only a variable inside the K-map cannot form a group, right? So whenever you want to group a variable, it should be with the same term or with one. If you had a D bar here, you would have made it as a pair. But here you don't have a D bar. So what you have to do, you have to make D bar, you have to group D bar with the adjacent one. So now, if I have to write the equation, F or f equals, so I'll consider this as my first equation, second equation, third, and this as the fourth group. So for the first group here, it is A bar. So A bar, can I stop with A bar? I cannot stop because here you have C as the constant. So A bar C. Along with that, you have to consider the variable inside the map also. So it will be A bar C D bar, right? Plus the second group, which is this one. So here it is A bar, and here the common constant one is B. So it is A bar B. Then should we include any variable here for the second group? We don't have any variable. So this is the final term. So for the second group, we'll have only A bar B because there is no variable in this group. And next for the third one, the vertical pair. So for that it is, according to the column, it is BC bar. And we have to consider this because it is entered inside the map. So it is BC bar D bar, right? Then there is one more single term there. So for that it is A B bar C. This is A B bar C. So this is your final solution. This will be the final equation using MEV method to solve this particular question. To solve this question, this is the final equation. So did you all understand? Any doubt in this MEV method? If don't care is there, can we group one and don't care term? See, when one is there, if it can form a larger group, of course you can group it. If one with a don't care forms a pair, right? So you can group it. If don't care is there, can we group one and? See, you have asked if don't care is there. Then again you're asking, can we group one and don't care? If don't care at all is not there, then how can you group one and don't care? Who is this? From 1 plus. I don't have the name here. Ma'am, what if there is a don't care in the 7th position? Okay, I'll just consider that. Ma'am, just a moment. Ma'am, please reply to the previous question. Previous question is this one, right? If don't care is there, can you repeat the question previous? There are so many here. Just a moment. Ma'am, in MEV, there's no redundant group. You have to consider redundant group here also. So in this example, good observation. I was just waiting for this question. Here already these ones are making a pair. Again, it is grouped in these two also. So this can be considered as a redundant group. So this will be a extra term. A bar B can be eliminated. Right? A bar B can be eliminated because it is already covered in D bar in these two. The first group and the third group, it is already covered. So this can be eliminated. And then, what was the other one? Ma'am, 1 and 1 is a redundant group. Yes, it is a redundant group. Correct. Then, ma'am, can we group 1 and 5? 1 and 5. I think this was for the previous one. Okay. That is over. Aishwarya, can you tell which is your previous question? Are you asking about the previous example? If don't care exists, can we group it with one? Yes, you can group it with one. can we group it? It means any variable, if it is inside the K map, you can group it with 1. If there is no, don't care. And then instead of taking 1 separately, can we group it with D dash above it? Yeah, it is done. So if there is no variable adjacent to it, then you have to group a single one. So first do all the groups, then find for the redundant groups, eliminate the redundant groups. Right? Over. This is what. So if you have any doubts in MEV method, just ask and we'll wind up. Then we'll start at 2 o'clock exactly, right? So afternoon session, it will be QM method. MEV problems are quite often rarely asked, but QM method is a compulsory method, compulsory question. It is for 10 marks. So please all of you attend without fail, right? In this question, A dash B is redundant, right? Yes. I just wanted to see if anybody is asking this question. I just was waiting for your question to tell, should we take this? Purposely, I did this redundant group. Good. Good that you all observed it. So this is the redundant group, so we need not consider it. So finally, we'll be having only 3 min terms here. So that will be, I'll just close this chat box just a minute. So here, if we eliminate the redundant group, the final equation will be F equals A bar C D bar plus B C bar D bar plus A B bar C. This will be the final equation which contains only 3 terms. This will be the minimal SOP equation through the MEV method. Right? So any more doubts? If no doubts, we'll just wind up. Ma'am, can we pair 1 and 5? Yeah, we have not paired it, right? Yes, of course, you can pair it. Do one pause sum for K-map. Yeah, anyway, again, we are going to do SOP and pause in module 3, that is combinational circuits. We again have the combinational circuits. In that, we do this SOP and pause, right? Yeah, of course, this also can be grouped as a pair. Either this, because here D is already grouped with this one, right? So you can either take this group or this group. So if you take this group, what happens? Instead of having a single one, you'll be having a pair here, and you'll be having this pair, you will be having this pair. So anyway, I think the term will change, but you'll be having 3 terms. You'll be having, even then you'll be having 3 terms, but the term will not reduce. See here in MEV method, single one with a group is better, because when you take a pair with a variable, that variable also has to be included. So whether we take this as a pair or this as a single term, it doesn't matter much, right? If you take this as a pair, then this will become redundant group. This you have to consider, and this becomes a valid group. If I take this as a pair and this as a pair, this as a single term, group 2 becomes a redundant group. So it all depends on how you take the groups. Of course, this is also correct. You can make D bar and 1, that is 1 and 5 as one pair. Then this becomes your second pair, and this becomes your third pair. I'll just show it here. I'll just show only the groupings. So 0, D bar, 1, 1, 0, 1, 0, D bar. So you can take this as a pair, this as a pair, and this as a pair. Or you can take 0, D bar, 1, 1, 0, 1, what we had done, you can take it as like that. So this can be a pair, this can be a pair, and this as a single term. So when we take either this or this, still it will be 3 values, 3 min terms. So it doesn't matter much. Only the term, the variables will change. Even in the previous problem, I didn't eliminate the reluctant node. It is redundant group. Which previous problem? What we had done? That is, you are talking about the one which we had. So we had a 1. Along with that, we had grouped the D bar. I think you are telling about this, right? So in this, the term for 1 is different and the terms for this pair is different. So we have to consider it. So here, this one itself forms a pair because it's already reduced. The min term for this one is different and the min term for this is different. So you have to consider both. It cannot be a redundant group. Here we have taken this and this one. You just have to observe the min terms. If they are same, then it is a redundant group. Otherwise, it is a overlapping group, right? So this has to be considered here because this gives only two. This gives a different min term, and this gives a. It means we can pair only one time with D dash. What do you mean by one time? Arvind? If there are two D bars, of course, if see, suppose you had a D bar here, you could have taken only this as a pair. Right, you could have taken only this as a pair. This is a different, this will give you a different min term and this will give you a different min term. So both have to be considered. Okay, shall we wind up? So we can meet at 2 o'clock. So shall we start after lunch by 2 o'clock? Okay. Okay then, thank you all. So we'll again meet back at 2 o'clock, right? Yeah, lunch break till 2. So all of you join back at 2 o'clock sharply. So next session will be on QM method, Quine-McCluskey method, which is very important. Bye.
100 ಇದ್ದರು 100 importance of importance.
Yeah. Quine-McCluskey method, or which is abbreviated as solve using on the module 2 topics, right? So first of all, why is this used? I'll move. Hello? And there was some disturbance in the voice. Can you all hear now properly? Is it audible now? Voice was breaking. Okay. Okay. Thank you. So we'll start with QM method. So that is Quine-McCluskey method, right? So the name of this is the name of the person who developed this procedure for solving the SOP equations, right? So this is mainly used whenever the number of variables are more than 4. Similarly, like MEV method, if it is used when the number of variables are more than 4. Even QM method is used when the number of variables are more than 4, right? But here we take the examples only for 4. So same thing can be implemented for equations with more than 4 variables, right? So in this, the steps have been described here. So first step is to determine the prime implicants. So whenever you are solving using QM method, the first step is to determine the prime implicants. So for determination of prime implicants, you have to follow these particular steps, right? So in the first step, when a problem is given, the problem may be given in the form of a canonical equation. So I'm just showing you this slide, the next slide. So here you have a problem which is telling you to solve using QM method. And the question is f of a, b, c, d equals summation of minterms, some minterms are here, right? So if the problem is given like this, first you have to write down the truth table. So write down the truth table for 0 to 15 and the output for 0 to 15, referring the question. So after that, after writing down this truth table, next step is just go to the slideshow. It is not in the slideshow mode, just a second. Slide. So first is 2 minterms will combine if they differ. So this is after writing from the truth table. So in the QM method, the main thing you have to observe is in the adjacent groups, you have to select two terms such that only one bit position in those two will change. So this is the key concept of QM method, right? So in this method, you have to observe the entries in adjacent groups and compare them and check if any one bit position is changing. So if only one bit position is changing, then you can merge them or combine them. So for example, here is an example. If you have two entries, adjacent group entries like 1011 and 1111. So here if you observe only the second position from left, right? Second position from left is changing. All the other bits are same. So in such case, you can combine these two terms as 1-11. So whichever bit is changing, that particular bit, whichever bit is changing, I'll just show you. So now in this example here, you can observe that this bit is changing and this bit is changing, whereas all the other bits are same. So in such a case, you can combine it, and at whichever position the bit is changing, that position has to be written as hyphen. Can you see this? Can you see the hyphen here? This is the position at which the bits are changing, right? At this position, the bits are changing. All the other bits are constant. So it is written as 1-11. Whereas in the next example, here you can see the first term is 1010 and the next one is 1100. Here second bit is also changing, third bit, fourth bit. So more than one bit is changing. If more than one bit is changing, then they cannot be combined. Cannot be combined. This is the key concept of QM method. So this you have to remember. So now before starting this particular action, before that you have stages, the stage one. So in stage one, what you do is the min terms are sorted into different groups. So whatever min terms you have in the truth table. So in the next slide, I have the truth table. So in this, I have the truth table here. So for whichever outputs the entry is 1, those binary numbers have to be sorted in the form that in the first group you should have only zeros, and in the second group you'll have all the terms with only one bit of 1, right? And in the third group you'll have all the entries with 2 bits of 1, like this as goes on. So each group will have common number of 1s. Each group should have equal number of 1s. So that is in the first step. Sort the min terms into different groups according to the number of 1s in each of them. So just listen, then when we go for the example, you can understand better, right? So after that, stage 2. So stage 2 is where you compare the elements of first group with the second group, and you do this merging operation, right? So second stage, compare all possible pairs of min terms and combine wherever possible. So for combining, you have to use this particular rule, right? And after that, similarly, stage 3, you have to repeat stage 2 procedure to see if one more bit can be combined. To see if one more bit can be combined, right? And after this, you have to write the prime implicants table. After the stage 3, it will not combine anymore. So after that, you have to write the prime implicants table. And after writing the prime implicants table, you will be finding or determining the essential prime implicants, right? So all this we'll see with an example. And while going from stage 1 to stage 2 and stage 2 to stage 3, you have to parallelly tick mark, put a tick mark. This is very important to keep you in track. So here, put a tick mark beside each minterm, which you have already considered, and also write down the decimal values in brackets. Decimal values have to be written down in brackets. So these two are very important. For these are your checkpoints, right? So if you are losing the track, it will tell you which terms have been already grouped and which have not been grouped. So to have that track, you have to write this tick mark and you have to enter the decimal values in the brackets. So these two things you have to take care. So now we'll go for the example, right? Yeah. So here we have the example. Just a minute, I'll erase all those lines. Okay. So this is the example, right? So this is the question here. So we have to solve for 0, f of a, b, c, d, summation of minterms 0, 1, 2, 3, 10, 11, 12, 13, 14, and 15. So for this, the truth table was shown in the previous slide. So here we'll see how the solution is done. See, from the truth table, you have to first sort the minterms into groups which contain equal number of ones. That is the stage 1. Can you see here? Stage 1. So in stage 1, you have to first sort the minterms into different groups having equal number of ones. So because 0 is there in the minterm, right? It is there in the minterm. For 0, the binary is 0, 0, 0, 0. Whereas no other entry will have all bits as zeros. So first group contains only 0, 0, 0, 0, whose decimal number is 0. So in the first stage also, you have to write down the binary value of the minterm, and in the bracket, you have to put the decimal value. Write down the minterm value in binary and also put the decimal value of the binary in the bracket, right? After that, next 1. So for decimal 1, the binary is 0, 0, 0, 1. So write down that in the next group because it has a single bit 1 and write its decimal value. Are you all following? And next 2. So binary of 2 is 0, 0, 1, 0. So this also continues, contains a single bit 1. So that will also come under second group. So if you observe, if you are thorough with the binary values, if you observe here, 3 has 2 bits of 1, 10 also has 2 bits, 11 also has 2 bits, 12 also 2 bits, 11 has 3 bits actually, 13 has 3, 14 has 3, and 15 has 4 bits. So none of the other minterms have single bit as 1. So we'll go to the next group. So if you are confused here, you can refer the truth table. You can first write down the truth table and then check the number of ones in each minterm, then group them, right? So first write down the truth table, then sort them into the groups containing equal bits of 1. So in the second group, you have the binary for 1 and 2. Next. So now we'll take the next term, which is 3, which has its binary as 0, 0, 1, 1. So write down the binary for that and write down its decimal value in bracket. Similarly, check next one. So 10 also has 2 bits of 1. So its binary is 1010. Write its decimal value. Then 12. So this is 12, which also contains 2 bits of 1. Write down its binary and its decimal value. Right? So similarly in the next group. So this is the third group. This is the fourth group. In the fourth group, you will have the entries with 3 bits of 1s.
Since the previous product.
Oh, I'm not sure. Share ಮಾಡುವಂತೆ.
ನೋಡಾಗಿಲ್ಲ ಮುಟ್ಟಿದೆಯಾ ನೋಡಿ.
Are you able to see the solution? Okay. Okay. So now I'll just repeat. So in the first stage, stage 1 here, you can see that in the first group, it has only zeros. So there is no other min term with only zeros. So that will form the first group. And in the second group, all the entries should have only 1 bit of 1s. Right? According to this min term, you have min terms which have 1 bit of 1s. So those will be forming the second group. And after that, the third group, which contains 2 bits of 1s. You can observe that each entry has only 2 bits of 1s. Similarly, in the fourth group, it has 3 bits of 1s. All the entries have equal bits of 1s. And the fifth group, all the bits are 1. So this is the stage 1. So in stage 1, you have to sort the min terms with their binary values such that each group contains equal number of 1s. So after each group, the indication of groups is the horizontal line. The indication of groups is through the horizontal line. So this line indicates that it is a group. So this line here indicates this is the end of first group. Similarly, after each group, you have to draw a horizontal line. Right? Next, coming to the second stage. So now what you have to do is, you have to compare the elements of first group with its adjacent group, that is second group. Compare all the elements of first group with all the elements of second group, and wherever only 1 bit position is changing, combine them. So this is the rule you have to follow. So we'll see how to do it. Now in first group, we have only 1 element. So compare this element with the element in the next group, with the first element in the next group. So when I compare these two, right? So here you have, I'll just write it here. In the first group, you have 0, 0, 0, 0. And in the second group, first element has 0, 0, 0, 1. So if you observe, only this particular bit position is changing, whereas all the other bits are same. So here you can combine these two terms as 0, 0, 0 hyphen. So at whichever position the bit is changing, that position should be indicated as hyphen. Right? So if you are able to combine the first element of an element from the first group to an element with second group, just tick those 2 elements. Whichever you are able to combine, put a tick mark beside them and write down the combined element in the stage 2. Write down the combined value in the stage 2. So after writing down that, you have to write down the numbers which are decimal values which are combined. So you have combined 0 and 1. So you have to write in the brackets 0, 1. right? You have to compulsorily write this. These only will put you into the track. They will make you aware which terms are combined and which are not combined. Right? Understood? Now, the first in the first group, we have only one element that is compared with the first element of second group. So now this has to be again compared with the other element in the second group, right? So for that, again, you just compare it 0, 0, 0, 0. Next 0, 0, 1, 0. So now these two also can be compared, can be combined or merged because it is changing only in this particular position. So after combining, it can be written as 0, 0, dash 0. So that is what is written here. Got it? So you have to merge the elements of adjacent groups by comparing and combining wherever possible. So when I compare these two groups, I will get the resultant as 2 elements. So where you can combine 0, 1 and 0, 2. So now you have to tick next to 2 also. You have to tick next to 2 also because 0 is again combined with 2 also. Now similarly, you have to repeat the same step with group 2. I'll just change the color. Excellent. Chal. Select green select. So now we have to combine the elements of group 2 and group 3, right? You cannot skip group 2 because it is combined only with group 1. Now we have to check group 2 and group 3. So now in group 2, consider the first element. Consider the first element. Now compare this with all the elements of next group. Compare this first element in second group with all the elements in third group. So the first comparison, right? 0, 0, 0, 1 and 0, 0, 1, 1. So only this particular bit position is changing. So it can be combined. Hence, we will write the combined merged value as 0, 0, hyphen 1 and also write in the bracket 1, 3. Write in the bracket 1, 3 and also put a tick beside 1 and 3. Put a tick beside 1 and 3 or only 3 because 1 is already done. You have to put a tick for whichever is not done. Right? 3 is done only now, so put a tick next to 3. Now again compare 1 with 10. So can you combine it? It can't be combined because you can see that this particular position is also changing. This position is also changing. This is not changing, but this is also changing. If it changes in more than one position, it cannot be combined. I'll just show you again. Show you here. So 1 with 10. Right? When we compare these two, it cannot be merged because it is changing at 3-bit positions. It has to change only at one position. All the other bits should remain constant. So that is the key concept of this QM method, right? So because it's changing at more than one position, it cannot be merged. So just leave it alone. Now compare 1 with the next entry, that is 12. So here also if you see, it is changing in more than 1 bit position. So this also cannot be combined. So these two cannot be combined. So 1 can be combined only with 3. Now check with 2. check, compare. Let's take a different color for this. Blue. Yeah. So now we'll take 2, right? We'll compare this with the elements of next group. So 0, 0, 1, 0, when I compare it to 0, 0, 1, 1, at this position, it can be combined because only this position is changing, it can be combined. Hence, this is written as 0, 0, 1 dash and the values are written as 2, 3. Both are already combined with other values, but again you can show this. So 2, 3 can be combined and put a tick if it is not ticked. Next, compare 2 with the next element here. So here it is 0, 0, 1, 0 and 10 is 1, 0, 1, 0. So it is changing only at this particular position. All the other bits are same. So you can combine 2 and 10. So write it as, because it is changing at this position, that will be written as hyphen and the other values will be written as it is. So other values are 0, 1, 0, 0, 1, 0. So write that. Then write in the bracket 2, 10 and tick 10. Write in the bracket 2, 10 and tick across 10. Then check 2 with 12. Again, this can't be combined because it is changing at this position as well as this position. When I compare 12 with 2, it is changing at 3 positions. So this also cannot be combined, right? Hence, between second and third group, these are the combinations that are possible, right? So now we have to check with third group and fourth group. Now we have to check with third and fourth group. Same step. Again, you have to continue the same procedure. Take the first element, compare it with all the entries in the next group. So when I compare 3 with 11, I can combine it and my merged value will be dash 0, 1, 1. Right? So can you see dash 0, 1, 1 because it changes only at this first position. So tick across 11, then 3 is already done. Write down here 3, 11. Next, compare 3 with 13. So this cannot be combined because it is changing at more than one position. Then 3 with 14 also cannot be combined because it is changing at more than one position, right? So next, we'll check with 10. We'll check with 10. So when we check with 10, 10 with 11, you can combine because it is changing only at this position. So the value for that will be 1, 0, 1, 1. Write down the merged value. Then in the brackets write down 10, 11. Right? Then put a tick mark. It is both are already ticked. So then again compare 10 with 13. So can it be combined? 10 with 13 cannot be combined because this is also changing. This is also changing. This is also changing. It cannot be combined. The next 10 with 14. 14, this is same, this is same. So this can be combined because it is changing only at this particular position. So the merged value will be 1 hyphen 1 0. So this is the value when you combine 10 and 14. 1 hyphen 1 0. 10 comma 14. Write down that and you have to tick 14. Right? Next, compare 12 with the next group elements. So 12 and 11 can't be combined because they are changing in more than one bit position. 12 and 13 can be combined because it is changing only at the first position, right? 1, 1, 0 hyphen. So here you have 1, 1, 0 hyphen. Then write the merged value and write the decimal values in the bracket. Put a tick mark for 30 because it is combined. Put a tick mark for 30. Then compare 12 with 14. So this also can be combined because it varies only at this position. So 1, 1, hyphen 0. Write down the values in the brackets. So this is also combined. So now all the comparisons between second and third group are done, right? All of them have done, and these are the values that have been derived after comparing and combining third group and fourth group. Now we have to repeat the same thing for fourth and fifth group. So after doing that, these are the results which you will be getting, right? So after you get this will also be ticked, right? So shall I go for the next stage? So shall I go for the next next stage? Okay. Okay. So in the next stage, stage 3, right? Now we have to see stage 3. In stage 3, the same procedure what you have done for stage 2, that should be repeated again to see if one more bit position can be combined. That is the concept of stage 3. The steps done in stage 2 has to be repeated for stage 3 to see if one more bit position can be combined. So what is the first step? Compare first group with second group to check if any bits can be combined. So here, just a moment, let's erase all these unwanted lines. I think this should have been there. Okay. I just put the tick marks because all were covered. So all these were covered and combined. So I'll put a tick mark beside everything. So this has to be there. Don't erase this. Right? Now you have to compare between stage 2, between the groups of stage 2. So first element is 0, 0, 0 hyphen. So just check with those terms which have a hyphen at this particular position. Anyway, other bits, if the hyphen is in some other position, you can't combine them, right? Please listen to this. In the stage 2 combination, when you're searching for combination in stage 2, between groups, check for the elements which have the hyphen at the same position. So for 0, 1, the hyphen is at LSB, right? Check if any term has hyphen at LSB. So this term has hyphen at LSB. So now check for the other bits. If in the other bits only one position is changing, then those two can be merged, right? So now you can merge 0, 1 and 2, 3. So after merging, you will get the result as 0, 0 hyphen hyphen. Understood? In stage 2, when you are going to combine, observe the elements with the hyphen at the same position. Otherwise, if you go on comparing this with all, your number of comparisons will become more. It will be more. So to reduce your time, what you have to do is compare the element with the same with the hyphen at the same bit position, right? So in this element, you have the hyphen at LSB. So check if any entry in the next group has hyphen at LSB. So this has. Then after that, check if all the other bits. Check for the other bits if they are changing in only one position. So this is changing only in this position, so that can be combined. Now, so this is over. This and these two are combined. So there are no elements with a hyphen at this particular position. So next, take the next element in first group. So here you have the bit position at this one, next to LSB, right? You have the hyphen at next to LSB. So at this position. So this also has the hyphen at this position. So only this bit position is changing, right? LSB is changing. So these two can be merged. So put a tick mark next to those two and write the combined value as 0, 0. These are constant. This is already combined. So this can be combined now. So write it as 0, 0, hyphen, hyphen. And write the values. So this is 0, 2 and this is 1, 3. Write down the values. Right? Understood? Now, is there any other element with the bit at the same position, with the hyphen at the same position? So there are no other elements with the hyphen at the same position. So comparison between first and second group ends here. It stops here. Now you have to compare the second group and the third group. Right? You have to compare the second and the third group. So in the second group, the first element is 0, 0, hyphen 1. Check for similar terms which have hyphen at this particular position. So if you compare, only this has hyphen at that particular position. Can I combine these two? These two cannot be combined because this position is also changing, this is also changing, and this is also changing. So I cannot combine 1, 3 and 12 and 14, even though the hyphen is at the same position. Next, go to the second element. So in the second element, the hyphen is at the LSB. Check for similar terms. So here you have hyphen at the same position. So now if you compare these two, this position, MSB position, right? This position, only this particular bit is changing. Otherwise it is 0, 1, 0. So these two can be combined and they can be written as hyphen 0, 1, hyphen. After that,
it becomes redundant.
so after that, write down the values 2, 10, 3 and 11. So here it is 2, 3 and here it is 10, 11. You write down in the same sequence, whatever it is here, or you can rearrange the values and write. So better you write in the same sequence. Here it is 2, 3 and here it is 10, 11. You have combined these two and put the tick mark, right? Now the third element in the second group. So if you see, the first element in next group also has the hyphen at the same position and only this particular bit is changed. So you can consider this also, but again this will be the same thing, that is 2, 10, 3 and 11, right? So this had to be written here, but because it is the same minterm, it is not shown here. Because it is the same minterm, it is not shown here, right? Whether you write or not, it's okay, but better you are write always, because later you can compare and redundant terms can be excluded in your prime implicant table. So repeat the same thing for, so this is over now. Comparison between second and third group is over. So this is the combined value. Now you have to compare between fourth and here it is third and fourth group, right? So compare all the elements from fourth and third group. I'll just erase this so that it will be clear, right? Now compare this element with next group. So there is no entry with a hyphen at this position, so this can't be combined. Next element, any element with a hyphen at this position, yeah, here you have. So observe the other bits. So this bit only is changing, so it can be combined as 1 dash 1 dash, right? 1 dash 1 dash. So write down the merge term and the values 10, 11, 14, 15. 10, 11, 14 and 15. Similarly, the next one, 1 dash 1 0. So here you have dash after 1. So these two terms can be combined. So for that also it will be 1 dash 1 dash. So again, it will be the same term, that is 1 dash 1 dash Write down the values 10, 14, and here it is 13, 15. 10, 14, and 10, 14, and 11, 15. So this and this. 10, 14, and 11, 15. So put a tick mark beside those two. Whichever is combining, put a tick mark. Getting it?
Not audible.
Hello? Can you listen to me? Is it clear? Is my voice clear? Hello? Okay. So after this, the second 10, 11, after that 10, 14 also over. Now compare 12, 13 with the next group elements. So 12, 13 at this position, you have an entry here. Before doing that, let me erase this. So now we are comparing 12, 13 and this one. This entry we are comparing with the entries in the next group. So here hyphen is at the LSB. So only this can be compared. So if you observe, this bit position is only changing. So these two can be combined. That is 12, 13 can be combined with 14, 15. So what is the value after combination? It is 1, 1, hyphen, hyphen. So this is the value after combination. 12, 13, 14, 15. Right? So this is over. Now check with this 1, 1 dash 0. Whether it can be combined. So this you can, if possible, you can combine with this. So these two change only at this particular position, right? Only at LSB they change. So these two can be combined, and after combination, they can be written as 1, 1 dash dash, right? So after this, we can, if there are no more combinations possible, just observe whether all the terms in the previous stage have been ticked, right? Just observe if all the terms in the previous stage have been ticked. So all the terms have been ticked. And further, they cannot be combined. So after this, next you have to draw the, or create the prime implicants table. Just erase all this. So now, after doing that, next step is to create the prime implicant table. So for creating the prime implicant table, you have to write the prime implicants. So whatever values are there in the last stage, those will be your prime implicants, right? Whatever values are in the last stage. Are you able to see the prime implicant table? So this is the prime implicant table. So here in the first column, you have to write all the prime implicants. So how to write this, I'll tell you. And you have to write the min terms in the columns. The rows will be representing the prime implicants, and columns will be representing the min terms. Whatever was there in the question, right? Whatever min terms are given in the question, these min terms have to be written in the columns. So you have to form as many columns as many min terms. So if you have 10 min terms, then you have to form 10 columns. If you have 4 min terms, then you have to form 4 columns. Likewise, here in stage 3, in the first group, you have 0, 0, hyphen, hyphen. So 0, 0 stands for A and B. So as it is 0, 0, it should be represented with A dash, B dash. Because in the first group, you have 0, 0, hyphen, hyphen. 0, 0 stands for A, the variable A and B. And because the value is 0, you'll be writing it as A dash, B dash. And after writing it down, whatever terms are covered, whatever min terms are covered, those you have to write down in the bracket. So for that it is 0, 1, 2, 3. So write down all the values. And of course, put a tick once, right? Then from the second group. In the second group, you have hyphen 0, 1, hyphen. So here 0, 1 represents the variables B and C. And based on the value, it can be written as B dash C. Because the value of B is 0, it should be represented as B dash. And value of C is 1, it is represented as C. Right? So write down the prime implicant based on the value in the stage 3. So after writing down the prime implicant, write down the numbers. So here it is 2, 10, 3 and 11 have been covered. So write down that. So after writing down, put a tick mark. Then in the third group. So third group, you have the first element as 1 dash, 1 dash, which is nothing but A dash, C dash, right? So that is A, C. So whatever is dash, that has to be eliminated or ignored. And wherever you have a value, either 0 or 1, for that particular variable, you have to represent it as A if the value is 1 and A bar if the value is 0, right? So this is AC. And for the last one, it is 1, 1, hyphen, hyphen. So that is nothing but A, B. So write down, parallelly write down the values, min terms covered with them. So these two also over and put a tick mark, right? So these two also over. So it is enough for the same min term, for the same value, if it is enough if you write down once. So now these are the prime implicants. So whatever you write here, these are the prime implicants. Understood how to write the prime implicants? Yes? So after writing the prime implicants, so beside the prime implicants, we have the values written, right? 0, 1, 2, 3. You would have already written the columns with the min term values. So whatever numbers you have beside this, below those numbers, you have to go on putting a tick or a below 1, put a tick. 2, 3 you have, below 2 and below 3, put tick marks, right? So similarly do for all the other prime implicants. So for B dash C, the midterms are 2, 3, 10, 11. So below 2, 3, 10, 11, the tick marks have been shown. Similarly for AC, the numbers are 10, 11, 14, 15. So below 10, 11, 14 and 15, the tick marks have been put. And in the last one, AB, the numbers covered are 12, 13, 14, 15. So 12, 13, 14 and 15. So these are the entries, right? So after doing all the entries, first observe whether all the min terms are ticked. At least one tick should be there below each min term. At least there should be one tick below each min term. Just observe if any min term is left without a tick mark. If it is left without a tick mark, that means you have left some value to be transferred as a prime implicant, right? So before going to stage 3, if there are some groups left without tick mark, that should also be taken here. And later it will be taken to prime implicant as a prime implicant. So that is why we need to have the tick marks at every stage. So there may be certain min-terms which may not be grouped. Here if you observe, all are grouped, here also all are ticked. If suppose any one is not ticked, that has to be carried forward to the next group. So you should not forget this. If any one entry has been not ticked in the previous group, carry it to the next group or the next stage, right? Carry it to the next stage. Same thing has to be done with the prime implicant. So now here anyway you don't have such entry. All the entries have been ticked. So after that, one more checkpoint is if at all you have forgotten to tick none of them, then one more place where you can check is after creating the prime implicant table, just observe below each column whether it has at least one tick mark. If at all it is missing, then you have to go back and check here stage 1, stage 2, and stage 3, right? So now all the entries have at least one tick mark. So first thing here you have to do is, once you complete the prime implicant table, you have to determine the essential prime implicants, right? You have to determine the essential prime implicants. So how to determine that? See here, below column 0, you have only one tick, right? Similarly, below column 1 also you have only one tick. So you have to encircle the columns with single ticks. You have to put a circle for the columns which have single ticks. Understood? And now whatever prime implicant is there for this particular row, now this becomes a essential prime implicant. So this is essential prime implicant, EPI, right? Because this has one tick means, then that is very much important. That has to be taken as the essential prime implicant. Similarly, in the last row, you have a single tick which are encircled. So this is also a essential prime implicant, right? So now write down these two. This is A dash B dash and this is AB, right? But now we have to observe in these two whether all the min-terms are covered. So further, whether it ends up here or you have to further check for simplification to see that you have to check whether these two essential prime implicants include all the min-terms. So if I observe in A dash B dash, 0, 1, 2, 3 is included. That is 0, 1, 2, 3 is included. And if I once observe in AB, 12, 13, 14 and 15 are covered. Whereas now which are left out here? Can you see? 10 and 11 have been left out. So 10 and 11 is neither covered in the first essential prime implicant nor in the other essential prime implicant. So there is one more term which has to be included. So you have to add one more term which contains 10 and 11. So now how to decide that? So this has, so if you observe here, 1 second. So if you observe in this table, B dash C also has 10, 11 and AC also has 10, 11. So your solution will have two different equations. You'll have a choice. So you can have either A dash B dash plus B dash C plus AB. This is B dash C is the term which contains 10 and 11. So it can be A dash B dash C plus AB, or it can have A dash B dash then AB. These two are essential prime implicants. Along with that, you can either include this or include this. So both equations are valid. This is also valid and this is also valid. Both are correct. Right? This is the final solution. So this is prime implicants table. Once you fill the prime implicants table, check for single tick marked columns, encircle those, and those rows, that is the prime implicants written in those rows, will form the essential prime implicants. And then check whether these essential prime implicants cover all the minterms. If at all they are not covering all the minterms, then check for the minterms which are left out and which prime implicants includes them. That also has to be your solution part. So this and this are the difference. You can create an equation with a dash b dash plus b dash c plus ab, or a dash b dash plus ac plus ab. Both are correct. Right? Understood? So this is the complete process for a QM method. Why you circle on 0 and 12? Because it contains. Okay. I need to observe single checked column. Yeah.
Yes, both.
Ma'am, should both be written in exam or only one equation? Both. Write both. It's better you write both. Even if you write one, it is correct. But to be on safer side, better you write both. If you write both, that means you know the concept very well. The examiner will understand that you know the concept very well. That is why you written both the equations. If you write one, he may assume that you have copied also. So better write both the equations. Right? Have you all understood QM method? Any doubts? EPI is essential prime implicants. Again, okay.
What are essential prime implicants?
Essential prime implicants are the most important prime implicants which will be included in the final equation. Right? Essential prime implicants. Essential itself tells that it is very important. As the meaning goes, the general meaning. Essential means it has to be included. So apart from essential prime implicants, so first how to find out the essential prime implicants. So I'll just repeat how to find the essential prime implicants. Then we'll go for the equation, right? Just a moment. See, while drawing the prime implicant table, first you'll write the prime implicants, and in the columns you'll write the minterms, right? So after that, for all prime implicants, see first in the first prime implicant a dash b dash, the numbers minterms covered as 0, 1, 2, 3. You have to put a tick below those columns. Here it has 0, 1, 2, 3. So put a tick mark below 0, 1, 2, and 3. Similarly for B dash C, which contains 2, 3, 10, 11. So below 2, 3, 10, 11. So can you see here at the top of the column you have the minterm values. So below those put a tick mark. Similarly for AC, which is 10, 11, 14, and 15. And for this it is 12, 13, 14, and 15. Right? So now all are ticked. So after ticking all, now we have to observe, to find the essential prime implicant, we have to observe which columns have single ticks under which column. See in this, for 0 column you have only one tick. So encircle it. Put a circle around it. Around the tick marks, put a circle which are single tick marks for that particular column. You have to observe the column, and whichever column has single tick marks, please encircle the tick marks. See, if you observe in column 2, the minterm 2, below minterm 2, there are 2 tick marks, so you should not circle it. Similarly, below 3, there are 2. Below 10 also, there are 2 tick marks, and below 11 are also 2 tick marks. So no need to encircle any of these. But below 12, you have only a single tick. So you have to circle it. Similarly, below 13 also you have a single tick, you have to encircle it, right? 14 and 15 have 2 tick marks, so no need to encircle. So after doing this, so whichever row coincides with the encircled column. So for this element, the row corresponding row is A dash, B dash. So this becomes essential prime implicants. So after writing the prime implicant table, putting the tick marks and encircling the single tick marks, whichever literals are corresponding to the single tick marks, those become the essential prime implicants. Understood? Whichever rows correspond to the single tick marks, those become the essential prime implicants. So if you observe here in the last row again, this is corresponding to the last row. So for this, the literal is AB, hence this also becomes EPI, that is essential prime implicant. Understood? So after finding essential prime implicants, you have to check with the minterms. So in this first API, you have 0, 1, 2, 3. So just put 0, 1, 2, 3. And in the last API, you have 12, 13, 14, 15. So tick for 12, 13, 14, and 15. So if at all some more minterms are left out, then this essential prime implicants is not the complete solution for the given question. So this tells that it is not the complete solution for the given question. So what you have to do? So you have to find a term which contains both 10 and 11. So here if you observe, this term also contains 10 and 11. This also contains 10 and 11. So you will get two equations because there are two prime implicants having the same minterms. You can either write the equation as E dash B dash plus B dash C plus AP or Y equals A dash B dash plus AC plus AP. See, these two are essential prime implicants, whereas this is a prime implicant which contains the minterms which were not included in the essential prime implicants. Right? Understood? Understood? Voice is breaking. What should I do now? Okay, did you all understand? Yes, did you all understand? Shall I go for the next one? Okay, thank you, thank you. So next I have a problem here. You just solve 2-3 minutes. I'll give you. I'm displaying the question here. Try to solve it. I'll give you a few minutes time. So later we'll check whether your answers are correct. So here's one problem with the prime implicant table and the question. So try to solve. Right? So will you all solve? Try stage 2 and stage 3. Yeah. Yeah, try for stage 2 and stage 3. Check if whatever the prime implicants have got is matching with your answers of stage 3. Has anyone done? Okay. I think all of you would have finished stage 2. So I'll try to do the stage 2, just compare. So 0, 0, 0. If I combine with, it can be combined with 1. So here I should write it as 0, 0. Did you all check how I am doing it? Yeah, I had not unmuted my mic. So now it is unmuted. I think you are able to hear now, right? So next, so 1 with 5 and 9 is over. Check 1 with 10, it cannot be combined. And next, so I have to tick mark 5 and 9, right? Then now compare, 1 is over. Compare 2 with the next group elements. First we had compared 1. So when I compare 2, 2 and 5 cannot be combined. 2 and 6 can be combined and the values will be 0, hyphen 1, 0. So in the bracket, write it as 2, 6, right? Then compare 2 with 9. It cannot be combined as it is changing in more than 2 positions. Then 2, 10 can be combined and the value will be hyphen 0, 1, 0. So here you have to write down 2, 10. Yeah, correct. And then any more from second and third group? So you have to now compare 8 with the adjacent group. So when I compare that, 8 with 5, it's not possible. 8 with 6 also is not possible, but I can combine 8 and 9. So I have to write it as 1, 0, 0, hyphen, right? Then in the bracket, write 8, 9. I have to take, I'll take it. And afterwards, 8 and 10 can also be combined. So it can be written as 1, 0, hyphen 0, right? And you have to write 8, 10. So you have to tick 8 and 9, 8 and 10. 6 is also included. So it is done here. So I have ticked it now. And next, so this is for the second group. I'll just shift all this. Right. So here I'll close the second group. Second group is done, right? Second group in second stage, it is done, right? Yeah. Now we have to compare the elements of third group and fourth group to see if any of them merge. So put a line here. Yeah. Check 5 with 7. So can it be combined? It can be combined. So you have to enter the value as 0, 1, hyphen 1. 0, 1, hyphen 1. And in the bracket, you have to write it as 5, 7. Right? And then next, I have to include some more columns here, rows here. So here, so 5 and 7 are done. So compare 5 with 14. Can you combine it? It cannot be combined because it is changing in more than one position. And 6 with 7, it can be combined. So it has to be written as 0, 1, hyphen 0, 1, 1, hyphen. It is 0, 1, 1, hyphen. And in the bracket, you have to write it as 6, 7. Then 6 with 14, this is also possible. So it will be 0, it is not 0. It will be hyphen 110. You have to write it as 6 comma 14. Right? So I have to include one more. So 6 we have compared for 7 and 14 and you could combine. Then compare 9 with 7. It is not possible. 9 with 14 is also not possible. Then 10 with 7 is also not possible. 10 with 14 is possible. So you have to combine it. So here you will combine it as 1 hyphen 1 0 and write the value as 10 comma 14. Right? Did you all get the same? So this completes stage 2. So 7 is ticked, 7 is included, 14 is included. Right? And then now we have to go for stage 3. So in stage 3, again we have to start comparing from first group to second group. You have 3 groups in stage 2. So first one, hyphen is at LSB. LSB is here, so I can combine. I'll just stick it off first. I can combine 0, 1 with 8, 9. I can combine 0, 1 with 8, 9. So I'll do the entries. So it is hyphen 0, 0 hyphen, right? We'll get the term as hyphen 0, 0 hyphen. So you have to enter the values, that is 0, 1, 8, 9. Right? Then compare, so no other term can be combined. Then compare 0, 2 with the terms of group 2. So it is in this position, in that position, 8, 9, you just check. It can be combined. So 0, 2 can be combined with 8 and 10. So you can combine 0, 2 with 8 and 10. So what will be the combined value? It will be hyphen 0. So while writing, it should be written as hyphen 0 hyphen 0. Hyphen 0 hyphen 0. And write the values as 0, 2, 8, 10. Right? Getting it? Yes, Tamana. Let me check. I think I have the equation. B dash, C dash, CD dash, yes. The result is fine. If you have got the same result, then it is correct. Whatever Tamana has posted, if you all have got the same result, then it is correct. Right? Anybody else who still not understood? Should I complete it? Got the same answer. Naveen also got the same answer. Anybody else? Anybody needs me to complete it? Yes, ma'am, complete please. Okay, Nishant, I'll complete it. Okay. So till here, it's fine, right? Did you understand till here, Nishant? So after this, you have to check. So 0, 2 can't be. Okay. So 0, 2 can't be further combined. So next you have to go for 0, 8. So at this first position, is there any? Yeah, this is there. So you can combine 0, 8 and 1, 9. So the term will be hyphen 0, 0 hyphen, right? It will be hyphen 0, 0 hyphen. So for this, you have to write the values 0, 8, 1, 9. Right? So you have to tick. 0, 8 and 1, 9. Then anything else? Here you have for 0, 8 and 2, 10 also can be combined. It is at the same position. So when I combine these two, then the answer will be, so it is hyphen at the first position, then 0, then again hyphen and 0, right? So it will be the same again, it will be the redundant term 0, 2, so here it is, sorry, 0, 8, 2, 10. Right? Getting this? Got it? And then any other combinations? So no other combinations as possible. So combinations between group 1 and group 2 in the second stage is over. So now you have to check between group 2 and group 3, right? So group 2 first element is 0 hyphen dash 0, 0 dash 0 1. So in that position, you can check only with this. So here it is changing in more than 1 bit position. So 1, 5, 10, 14 cannot be combined even though the hyphen is at the same position. Right? Are you listening? 1, 5 and 10, 14 have the hyphen at the same position, but still they cannot be combined because they vary in more than 1 bit position. Right? Then check with hyphen 001. So here you have hyphen 110, but again these two also cannot be combined because here also the changes are in more than 1 bit position. So always remember that you can combine only if the change is in 1 bit position. If only 1 bit changes, then you can combine. Otherwise you cannot combine. Any stage that has to be remembered. Right? So 1, 9 cannot be done. Then 2, 6 hyphen at the second position. So this is 0 hyphen, so same thing. This also cannot be combined. Then hyphen 0. So this also we saw 1, 0, 0 hyphen. So here you have the hyphen at the end, but still you cannot combine 1, 0, 0 hyphen and 0, 1, 1 hyphen because it is changing in all the 3 positions, right? Then 1, 0 dash 0. So this position, even this cannot be combined because it is changing in more than 1 position. So these are the combinations that is possible. So more than this you cannot combine. These are the only possible combinations. So all this, if you observe in this particular stage, see this is not ticked, this is not ticked, I think, yeah. 2, 6 is also not ticked. Then 5, 7 is also not ticked. 6, 7 also not ticked. So all these 4 in the last group are also not ticked. All these have to be carried forward to the next stage, right? So now this will become the first group of stage 3, right? And after below that you have to write down from the previous group, whichever is not ticked. So here you have 0, I'll just so here 0 hyphen 0, 1. 2, 6 can be combined with 10, 14. Yeah, 2, 6. Yeah, 2, 6 can be combined with 10, 14. Correct. Good. Gunal. So I have to erase this. Where is that? I have to erase the line. So here it is 0 hyphen 1, 0, right? Yeah. Hyphen 1, 0. 2, 6, what is that other one? comma 6, 10, comma 14. Correct. Comma 6, 10, comma 14. So these two are now ticked. Right? So any other such missing groups or missing combinations? 2, 6, 10, 14. Yeah. So now we can close this group. So after closing the group, check for unticked terms in the previous stage and write down those terms. So here I'll start with the next group. So here you have 0-01. Parallelly write down the values also 1, comma 5. Then in the next one it is 0, 1, hyphen 1, which has the min terms of 2, comma 10. Then sorry, it is not 2, comma 10. It is 5, comma 7. Then you have 6, comma 7, which is 0, 1, 1, hyphen. So this comma 7, right? And then 6, 7. So now I will just put a tick here. Otherwise it will be confusing. So this over, 6, comma 7 over. Now I have to write down this last one, 6, comma 14. So here it is hyphen 1, 1, 0, which, right? So now all these are the prime implicants. So here if you see this is same as this. And what is the prime implicant for this? It is B dash C dash, right? You got the prime implicant of B dash C dash for these two. Next you have again these two are same, 0 hyphen, dash 0, dash 0. So this is B dash D dash, right? So you got the second prime implicant, which is B dash D dash from these two. So this you have to just always remember the MSB is A, next is B, C and D. The values whatever are shown here, from left side it is A, B, C, D. So if the value is 0, take the variable with the complement. If the value is 1, write the variable with without the complement, right? 2, 10, 6, 14 is combined, right? 2, 10, 6, 14. 2, 10, 6, 14 will get mapped on. Yes, correct. So here 6, 14 we can remove because it is already covered here. We'll get again, it will get the same prime implicant. Even though we have left out here 2, 10, 6, 14, I took it to the next group because it was not mapped. But if I combine, you can see here 2, 6, 10, 14 or 2, 10, 6, 14, both are same. So this, right? This is nothing but the same as 2, 10, 6, 14. So now we have written for these two. So next I have to write for this. So this, the min term for this is C D dash. So this is C D dash, which covers 2, 6, 10 and 14, right? So this, if I move the screen, the ticks are getting changed. So don't observe the ticks now, because if I move the word pad, it is not, the ticks are not moving. So that is on the screen. So now this is done. 2, 6, 10, 14 is done. So this you need not, 6, 14 you need not consider because it was already added in this 2, 6, 10, 14, right? But 6, 7, 5, 7 should be there because 7 is in none of the prime implicants. Similarly, 5 is not there in any of the prime implicants. So these have to be written as prime implicant. These three have to be written as prime implicants. So for that, here you have A dash, C dash, D, right? A dash, C dash, D. And here you have A dash, B, D. This is A dash, B, D. And that's it. 6, 7. 6, 7 is A dash, B, C. This is A dash, B, and C. Right? So you have got the prime implicants. So after getting the prime implicants, now you have to find out the essential prime implicants. After getting the prime implicants, you have to find out the essential prime implicants. So for that, see for B, C dash, B dash, C dash, we have 0, 1, 8, 9. So for 0, 1, I'll just type it here. I'll just put a star because here I cannot put a tick mark. I'll just put a star, right? Then 0, 1, 8, 9. Then for this it is 0, 2, 8, and 10. Right? Then for 2, 6, 10 and 14. 10 and 14. Then here you have 1 and 5. 1, 5. Then you have 5 and 7. Then you have 6 and 7. 6 and 7. Right? So is there any column left out without any entry? So here also it's there. So all columns have been filled. That means the prime implicants are okay. So after this, now we have to check if any column contains a single. Assume this as a single tick mark. So here in 14 you have a single tick mark. So you have to circle it, right? In 14 you have a single tick mark. So circle for this. And anywhere else? Yeah, under 9 also you have a single star. So this also has to be circled. So here you have 2, 2, 2, 2, 2. So these two become the essential prime implicants, right? So these two, that is BC dash and C dash, become the essential prime implicants. Now to find the complete solution, what you have to do is tick all the prime implicants, that is min terms present under these essential prime implicants. So you have 0 here, 1, 8, 9. Then here you have 2, 6, 10 and 14. So which is left out now? 5 and 7 are left out. So just find a prime implicant which has both 5 and 7. So if you observe that here in A dash BD, you have both 5 and 7. So this forms your other essential prime implicant. So this will be your equation, that is B dash C dash, CD dash and A dash BD, right? So this will be your equation. So now after that, so now you can see that all the min terms have been covered. So what you have to do next is you have to write the equation. So here below this, I'll just write the equation. So the equation will be F equals, right? So first prime implicant is B dash D dash, B dash C dash. Because I have moved the page, the tick marks have been changed. Then you have CD dash C D dash plus. Next you have 5, 7, which was A dash B and D. So this is your final equation, right? Understood now? Understood? Anybody having a doubt? So many people will do the stage 1, stage 2, and stage 3. But when it comes for prime implicants table, people will not have prepared for it, thinking that this is easy. But please remember this, until you write the prime implicants table, you cannot find the essential prime implicants. And until you find that, you cannot complete the solution. So after you have done from stage 1 to stage 3, this is not at all difficult. You can easily do it. You just have to plot them in the table, then find the single text, and the corresponding row will be the essential prime implicants. After that, check if all the minterms are being covered by the essential prime implicants. If at all they cover all the minterms, that will be your final equation. If it is not covering, then check for the remaining minterms which are not covered if they are present in any other prime implicants. So add that into your equation and that becomes the final solution. Is it clear? Anybody having any doubt? Okay. Someone asked me to complete it, right? Who was that? Akshata.
Nishant.
Nishant, did you understand? Okay. So next is in the QM method, you have something called as Patrix method. So it will take another 5 minutes. So after this, I'll stop. Then we'll discuss the questions, right? I'll just erase all this. So in Patrix method, till the prime implicant table, it is the same. So if you are asked for a question to solve QM method using Patrix method, till the generation of prime implicant table, the steps are same. You have to generate the prime implicant table, and after generating it, see, this is the Patrix method. After generating the prime implicant table, what you have to do is, as in the previous step, you have to encircle the single text, and those will become your essential prime implicants. So these prime implicants have to be removed. So after removing the prime implicants, please listen. For Patrix method, you have to first prepare the prime implicants table, right? You all know now how to prepare the prime implicants table. You have to prepare it. After preparing it, here you have the prime implicants, right? So name each of them with a different function. So here P is a function, Q is a function, Q, R, S, T, U. All these are different functions. You can either name it as P, Q, R, S, T, U. Means these should be different from the variables which you have used. If you use X, Y, Z here, then here it should be A, B, C, D. Here I have used A, B, C, D. So this I can take any other alphabets other than the alphabets used in the question, right? Or you can just name them as P1, P2, P3, etc. You can name them as P1, P2, P3, P4, P5, and P6. So give a function name for each of these prime implicants, right? So after that, observe if there are any essential prime implicants. So remove them. Remove the essential prime implicant. So here I'll remove P and S, right? Because they are the essential prime implicants. So after removing them, now remove the columns where the minterms for these essential prime implicants are present. So this contains 0, 1, 8, 9. So remove all those columns. You have to remove the columns present under the essential prime implicants, right? So 0, 1, 8, 9 are deleted. Then in this next essential prime implicant is CD dash. So that contains 2, 6, 10 and 14. So those columns also have to be removed. 2, 6, 10 and 14 also have to be removed. So now what are remaining? Only 5 and 7. Only these two columns are remaining. So now write down the table again only with these two columns. So it is, so Q also you can leave off because it doesn't contain any entry for 5 and 7. So you can write down only S, T and U. So this is your table now for the Patrix method, right? Is it clear till here? Did you all understand till here? So after getting the prime implicant chart, after drawing the prime implicant chart, you have to first name each function, right? Name all the prime implicants with a function, then eliminate the essential prime implicants. Remove the essential prime implicants and their corresponding minterms. Remove the rows of the essential prime implicants along with the columns of their corresponding minterms. Please remember this. Before applying, see here, before applying Patrix method, remove all the prime implicants and the minterms they cover from the chart. So after implementing this step, right? After implementing this step, I have the prime implicant table has been reduced to this size. Can you observe? So after getting this, now what you have to do is, sorry, excuse me. So now we have to consider the remaining functions. So see here, S and T has 5. To get 5, you have to consider both S and T. So you will be writing the expression as E equals S plus T because S plus T is required for 5. And 7. 7 is not covered in essential prime implicant, so that can be achieved by T plus U. So you will be writing T plus U, right? Plus the essential prime implicants which you removed before. So that was P and R. So this will be your expression after you have removed the essential prime implicants and considered the columns which were columns of the minterms which were not present in the essential prime implicants, right? So these are P and R are essential prime implicants, and S plus T and T plus U are for the minterms 5 and 7. 5 is present in S as well as T, 7 is present in T as well as U. Hence you write the equation as S plus T into T plus U plus the essential prime implicants. Understood this equation? Yes? Okay. Next. So after this, now using the Boolean law, you have a law telling that A plus B into A plus C is equal to A plus BC. So using this law, you can rewrite this as PR as it is, you'll write down. So these two can be reduced as T plus SU, right? These two can be reduced as T plus SU. Then again, you multiply R with T, it becomes P into RT plus RSU. Hope you all can see it. Or should I increase the font? Okay. Just a moment. I'll just erase all this. Okay. So can you see here? So first you reduce these terms using this law, then it becomes t plus su. Then you have to remove these brackets. So after you multiply and remove the brackets, it will end up with PRT plus PRSU. So
Please repeat after elimination.
one second. Ma'am, please repeat after eliminating. Okay. Shall I complete of this and repeat? I'll just complete of this so that it will be a repetition from there. So after eliminating, you'll be getting these functions. Because 5 is present in S and T, we'll be using it as S plus T. And 7 is present in both functions T and U, so you have to write it as T and U. Then you have to consider the essential prime implicants which we removed in the beginning, right? P and R. So after that, now these two functions can be reduced using this Boolean law. So when you use this Boolean law, these two can be written as T plus SU. So after writing this, so just multiply them and remove the brackets. So when you multiply these two terms, you'll be getting it as RT plus RSU. Then again multiply that with this P, you'll be getting it as PRT, the product of these two, and PRSU, which is the product of P and RSU, right? After getting this, now in equation 4, show that there are two irredundant soft functions. Means these are different functions. They are not redundant. They are irredundant soft functions. So these two tells that whichever is minimal. So as soon as you see this, you can see that one term has 3 variables where the other term has 4 variables. So whichever has the less number of variables will be your solution. Whichever term has the less number of variables will give your solution. So here if you observe PRT has only 3 variables, so that should give you the answer. So after that, after observing that, then F1 is ABCD is equal to PRT. So what is the value for P? You have to go back to the prime implicant table. Value of P is B dash X, C dash. So it is B dash C dash, and value of R is CD dash, right? So write CD dash here, and value of T is A dash BD. So you get A dash BD. So once you find out this, just again replace these functions with their actual literals. And this is the solution using Patrix method, right? You have two options here, but the one with the minimum variables will give your solution. This is the solution, but both are irredundant, right? Yeah. Okay, so I'll just recap it once again. Please listen now, just 2 minutes. So for Patrix method, because I have not done in the class also, I think most of you would be requiring for a recap. See, till the step of prime implicants table, Patrix method is same. Whatever you follow for QM method, till this prime implicants table, it is the same. So after you write the prime implicants table, first thing you have to do is write each prime implicant as a function. Write each prime implicant as a function, give it a name for each function. So here I have taken P, Q, R, S, T, and U. So after writing that, check if there are any essential prime implicants. So I have 9 and 14. So that is P is a essential prime implicant and R is also a essential prime implicant. So I have to remove the essential prime implicants and the min terms corresponding to the essential prime implicants. So here you have 0, 1, 8, 9, right? And here you have 2, 6, 10, 4. So after eliminating these rows and the corresponding columns, your table will be reduced to this size. So in this table, I have removed the essential prime implicants and their corresponding min term columns also, right? I have eliminated it. So after eliminating, now what are the remaining functions? You have S, T, and U. Q is not considered because it doesn't have any entry here. So you need not consider Q. Whereas S, T, and U have a entry. So here if you observe, for 5, for representing 5, you can consider S and T. So write that as S plus T, right? So after eliminating the minterms, essential prime implicants and their minterms, you'll get this table. After getting this table for this particular minterm, now consider the first minterm in the reduced table. Here you have 5. So where all is 5 present? 5 is present in S as well as T. So for 5 to be considered, it is written as S plus T, right? Similarly for 7. For 7, it is written as T plus U because 7 is present both in T as well as in U, right? Then you have the essential prime implicant functions, which I have already removed it. Before this table only I had removed it. But for the final solution, you have to include them also. So you write along with the functions derived from the supplementary table, you have to include the essential prime implicants also. So that is P and R. So after that, using this law, these two will get reduced, right? It will get reduced as T plus SU. So now remove the brackets by multiplying each term. So when I multiply R with T plus SU, it will result in RT plus RSU. Then again multiply P with RT plus RSU. So it will result in PRT plus PRSU. So after this, now observe these two terms, whichever has less number of functions. These are all functions, right? Whichever has less number of functions, that will be your optimal solution. Whichever term has less number of functions, that will be your optimal solution. You can write the solution for both the terms, but finally you have to conclude saying that the term PRT is the optimal solution as it contains the less number of functions. So this is your answer. Understood? This is nothing but the Patrix method of Quine-McCluskey solution. Understood? So for any method, when you use either MEV method or QM method, you can of course verify it using the K-map method, but you have to be careful that you do the groupings properly here. If you again don't do the groupings properly here, you may end up with a different answer where you may not be able to find whether this answer is wrong or that answer is wrong, right? This is one option which you can do for verification. Ma'am, can you once do Patrick method for the first sum we did at 2 p.m. Okay, first sum. Will you try it today and check, because these are the same steps for whichever sum. You just try it today. You are from AMC only, Nishant? From which college? GIT. Okay, good. So for this sum you are asking, right? For this one. Can you see the screen? So you're asking for this sum, right? Yes. Okay. So here, it'll take only 2 minutes. Let me finish it off. Just a moment. So I'll take the annotation. So till here it is same, right? So till here it is same. So you have to eliminate, first name them as P, Q, R, and S. So you have 4 functions here. So P will be eliminated and S will be eliminated, right? Then you are left out with BC, B dash C and AC. So here the columns 0, 1, 2, 3, then 12, 13, 14, 15. All these will get eliminated. So you will be having a table only with BC dash, B dash, C and AC. Right? You'll be having only these two. So here you have 10 and 11. So 10 is present in both. So again, it will end up with the almost the same equation. Just a moment. So BC has please others don't leave as we are going to discuss the university questions also. Just a moment, I'll just finish this and we'll discuss the questions. Later you can leave the meeting, right? Or at least we'll give the questions, try to solve it. So in the tomorrow's first session, you can ask for, we'll verify with the solutions. And the answers are also given in the questions itself. So here you'll be left out with, what is that? Q plus R. So this will be your equation after eliminating the essential prime implicants. So this is AC into A plus C. Right? Yeah, here, what is this? This is not A plus C, sorry, this is Q plus R, and it is only Q plus R. So I can remove even this. Q plus R into P into S. So just remove the brackets, multiply and remove the brackets. So whichever gives you, and here I think you will get both, both will be valid. You'll have both the terms with equal number of variables. I think that was your doubt, right, Nishant? Here you'll get both the terms with same number of variables. Yeah. So this answer is also same, right? Both are valid, right? So at that case, if both the terms are having the same number of variables, then both answers are valid. Here also we have got similar. So that is also correct. Is it clear? Is your doubt clear, Nishant? So both the terms will be valid. You can again show the answer as either this or that. Both are valid equations. Right. So now Shalini ma'am will discuss the questions. So once the questions are discussed, then we can leave the meeting. Okay, over to Shalini.
Good afternoon, everyone. Please don't leave the meeting. So from morning, you're learning so many things. You're getting revised with so many concepts, right? So I'm very happy that you are very interactive throughout the session and you did not feel tired or losing enthusiasm or something like that. So what is the use if you don't know what type of questions came in exam, right? And how to answer them. So we shall end this today's session, the whole day session, with question bank and previous year question papers. So let us see some of the important questions that has occurred. We are projecting question bank and previous year university question papers. So we shall go through the questions. So what is SOP pause? Give an example for standard SOP pause, right? So all of you know the answer for this. If you have any doubts, you can post in chat box regarding any questions. The second one is name the basic gates with a symbolic representation with truth table and waveforms. So waveforms are very important to represent basic gates. If you don't understand the way to write the waveforms, tomorrow we are again taking a session where we are teaching you how to write the waveforms for the gates. Okay. And the next question is, what are prime implicants? Explain with an example. I think you know what are prime implicants. Just now ma'am told so many things about prime implicants, how to get the prime implicants, right? So prime implicants are the implicants that belong to a particular function. All the expressions that are present. See, for example, if you take f of a comma b comma c, then I write a bar bc plus abc plus ab bar c, something like this. So they are all prime implicants. Okay, so it depends on what type of question you are taking, right? Explain with an example. Okay. The next question is, what is logic design or digital logic? Mention its applications. So what is logic design? Logic design is nothing but the designing of circuits with gates to get the required output. Okay. We are using logic design in many of the applications, like serial set, what you use, like in functions you use, right? Those kind of serial set lighting, and they are used in digital displays. You can see that the traffic display, right? Automatically the number keeps changing, right? So there also we are using logic design. Where not, in every field we are using logic design. Even your mobile phone uses the concept of logic design, right? Your computer, everywhere you are using the concept of logic design. As we told in the beginning itself, the whole world is digitized, right? Okay. So the next question is, name the universal gates with their symbolic representation, truth table, waveform. The next one is, give the truth table representation of f of a comma b comma c d with these mean terms. In the morning session, I revised about this topic, how to write the truth table, right? So you have to write the truth table for all this. That is, whatever the mean terms that are mentioned in this function, for that mean term you have to mark 1, right? And what is the question again? And draw the logic circuit. Finally, you have to end up with a logic circuit with basic gates. Okay, such type of problems usually occur. The next one is, what is a literal? In the morning session, I told you what is a literal. A single term in the expression is called a literal, right? Prime implicate, right? So prime implicant is the word that is used when we use SOP. In SOP, we use the word prime implicant. In pause, we use prime implicate. Instead of prime implicant, we use the word prime implicate. Then Standard pause and standard stop. In the morning session, I told you function becomes a standard pause or standard stop. Suppose it contains all the literals that are present in the function. If any one literal is missing in a particular expression, it won't become a standard stop or standard pause. Then solve using K-maps, MEV method, Quine-McCluskey method. These are all very, very, very important questions. K-maps you can expect around 10 marks to 15 marks. MEV method around 10 marks. Quine-McCluskey method 12 to 15 marks you can expect. Okay, so you don't leave these methods. K-map method of solving that is both SOP and pause. Don't leave them. Try to group them properly, try to obtain the circuit diagram. MEV method is also very important. McCluskey method is also very important. Okay. And then Patrix method is important, but it is extension of McCluskey method, right? In McCluskey method, you use the tabular method, right? At the end. So you have little change in Patrix method. That is what you observed today. Then problems discussed in previous year question papers. Let us see what are all the problems that has occurred in the previous year question papers in all these topics. Okay, I'll share it 1 second. Okay, I hope you can see the screen. University questions, module 2. What are all the university questions that have occurred in the latest? They are given here. The first question is simplify the given Boolean function by using K-map method and give the implementation of the simplified expression, right? So sigma m, you can observe here, sigma m is only 7 and don't care 10, 11, 12, 13, 14, 15, right? So answer is also given here. Try to solve all this, okay? And find the minimum SOP form of the given minterms using K-map. Minimum SOP is nothing but after simplification, whatever you are going to get at the end. Using grouping and all, at the end, what are you going to end up with? That is called minimum SOP, okay? Find the minimal SOP for the Boolean function. See, K-map, for 5 marks it has come, 5 marks it has come in Jan 18, February 9, and July 17th also it has come. You can see both the questions they have asked. Sigma m they have asked once and pi m they have asked. Find minimal SOP. And answers are given here. The next one is find, 1 second. Simplify the following function using K-map, design it using NAND gates. So you have to design this circuit using only NAND gates. And the fifth one is a digital system is being designed. You just observe the fifth question. A digital system is to be designed in which the months of the year is given as input in 4 bits. January is represented as 000 and February has 001 and so on. The output for the months with 31 days is 1, else 0. Consider the excess inputs beyond 1011 has don't care conditions. So how are you going to solve this problem? It is a very easy problem, but the question is little complicated. If you understand the question properly, you can easily solve. How will you solve this? Think about this. I want a reply from you. How are you going to solve this? Any idea? Can you post it in the chat box? 1 second. Yeah. How will you solve this? Fifth question. A digital system is to be designed in which the months of the year is given as input in 4 bits. So how many bits you need to take? You need to take 4 bits. This question has repeated 3 times. I want you to solve this particular question today itself. Okay, so I'll just give you a hint. Tomorrow, I think I will be ready with your answers. You should, I want to see your answers. Okay. So how are you going to do this? There are 4 bits, right? So 4 bits is A, B, C, D. I can take A, B, C, D has 4 bits. And January is represented as what? 0, 0, 0, 0. Okay. So then February is represented as 0, 0, 0, 1. Right. So till where you need to continue like this? Till where? Till where I need to proceed? Come on, tell me. Till December. So it will go to till what is 1100? You have given the answer as 1100. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. 2 cube is 8. 8 plus 4 is 12. Is it correct? Because we are starting from 0. 11. Yes. How are you going to write 11? How are you going to write 11? 8 plus 4 is 12. So I can write 11 like this. 1, okay. 1, 0, 1, 1. So what is 1, 0, 1, 1? This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. 2 cube is 8. 8 plus 2 is 10. 10 plus 1 is 11. So this is correct. 1, 0, 1, 1. Yes, correct. Good. So till 1011 you need to write. Okay, then what I should do? What I should do? So till 1011 I am writing. Then what I should do? The output for the months with 31 days is 1. So then you need to consider C. So after this also I will be having, right? So 1011, then 1100. For all this I need to take don't guess. I need to take don't guess from here onwards. So here what I should do? The output, the function is the function they are telling it as. So the output for the months with 31 days is 1. I hope you know which months have 31 days, right? Your nursery rhyme, 30 days are September, April, June and November. So based on that, the output of the months with 31 days, put 1 and else put 0. So the function column will be ready, right? And consider the excess inputs beyond, that is beyond 1011, what you should consider it as don't care in the function column. I hope you are understanding. You have to solve this and tomorrow you should tell me the answer. I'm just giving you the hint. Okay. So for this system of 4 variables, find the following. So what you should do? You should do SOP and POS, both sigma m, pi m. And you have to write the truth table. So truth table for a SOP is this one, right? So for truth table for POS is reverse of that. You have to put zeros instead of ones. Then using K-map, simplify the Boolean expression. Then you have to use K-map also to simplify the Boolean expression. Okay. Then implement the simplified equation using NAND gates. You know, in your electronics in the first year, you have studied how to replace the basic gates with NAND to NAND gates, right? You are going to put bubbles before, after, you are going to cancel the bubbles, right? So solve it. Tomorrow I'll be expecting this answer. Please write it, okay? And show how it can be done, okay? I hope you're okay with the hint, whatever I have given. Yes? Okay. The next answer is given here. If you get this answer, I hope you will be the correct path. The next question is, sixth question. The system has 4 inputs. The output will be high only when the majority of the inputs are high. So even this is an important question. I have seen this question many times in the previous year question papers. Sixth question. It is an important question. Okay. The system has 4 inputs. So again, you need to take 4 bits, A, B, C, D, right? The output will be high only when the majority of the inputs are high. So keep writing the combinations from 000, 0001, 0010, keep writing till 111, right? So what is that they have told? The output will be high only when the majority of the inputs are high. Majority of the inputs where they are high, for in case if you consider the last combination. So then in the function column, the output will be high, right? So wherever ones or more than zeros for that particular column, put high. I think you are getting that. Okay. So similarly, as they asked in the previous question, you have to give the truth table and simplify using K-map. So take this function. I told you in the morning session how to write the K-map for the truth table. Then Boolean expression, both in sigma form and pi form, and implement the simplified equation using NAND to NAND and NOR gates. I hope you know about writing NAND gates. You have any doubts in that? If you have any doubts, we can clear in tomorrow's session. And the answer is given here. You can try this. Then I think this 5th and 6th, they're all not direct type of questions. So coming to the 7th question, design a logic circuit to provide an output when any 2 of 3 or 4 switches are closed, right? They have asked in July 2018, assume that switch open is 0 and switch close is 1. So how are you going to project this? Design a logic circuit to provide an output when any 2 or 3 or 4 switches. So how many variables you are going to take? How many variables you are going to take? Again, you need to take 4 variables. This is the clue, right? So you need to take 4 variables, A, B, C, D, right? So design a logic circuit to provide the output when any 2 or 3 or 4 switches are closed. So they have also told that the switch open is 0. See here, you should be careful. Switch open is 0, switch close is 1. See what they have given here. So for different combinations, write the different combinations till you reach 1, 1, 1, 1 and write the functions. Okay. So when switch open is 0 and switch close is 0, when any 2 or 3 or 4 switches are closed, 3 more than 3, that is 3 equal to and greater than equal to 3 zeros are there, then what happens? Put 1. Okay. So when greater than equal to 3 are there, put 1. Okay. So then based on this concept, you keep writing the function, then you will get this answer. Then simplify the following Boolean function using Quine-McCluskey method. Just now, Jai Shubha ma'am told you how to solve this Quine-McCluskey method. Look at the marks. Look at the marks. How many marks? The huge 10 marks. See, if you learn that Quine-McCluskey method properly, most probably you were, what I can say, 10 to 15% of your passing marks you can get from that. Isn't it? So don't leave Quine-McCluskey method. Many people think that it is tough. It is not tough, but it is little lengthy. It is easy, but it is lengthy. You should have patience. You should write legibly, neatly, then only you will get answer for McCluskey method. Okay. Then coming to the next question, 9th question. Again, it is a Quine-McCluskey method, which is important. See the marks. It is for 10 marks. And don't think that in 2017, 2016, it has not occurred. In each and every question paper, it has occurred. We have put the important questions here, which has occurred. Okay, Quine-McCluskey method is very, very, very important. And then coming to, okay, there are 9 questions. So if you are interested, you can solve these, but don't leave 5th and 6th. It is somewhat unusual type of question. Okay, so this is what we could get from the previous year university question papers. And I think you can get around 20 marks if you study module 2 properly. If you study module 2 properly, you can get 20 marks out of 100. That is minimum, 20 to 25, I can say. So, and it is not tough, and you need not study the day before exam if you know the concepts. So study well. Module 2 is easy. And today you have understood about tabular method, Quine-McCluskey method, both are same, right? Then you also understood how to solve Patrix method also, right? MEV method, they are all important. Okay. Okay. Some doubt?
They want to share the question.
Yeah, we are sharing. See, day-wise folder we are sharing with you. Okay, day 1 what we have done, we are going to share with you. Okay, module-wise question papers, question bank, notes, module 2 notes, everything we are going to share with you in folder form. We will provide the link. We are deciding on that. We are going to provide the link. By tomorrow at max, you are going to get this. Don't worry about that. We are going to provide everything for you. Okay. We are going to share all the things. So tomorrow also we are starting by 10 o'clock. Tomorrow directly we are going to start. So please ask your friends also to join. Tomorrow we are starting module 3. Yeah, so Nishant asked, you will share through mail, ma'am. Nishant, we have to discuss with a workshop coordinator in our department. I will discuss with him and her, and we will let you know. Surely we are going to give, don't worry about that. We are going to give university question papers, question bank, notes of module 2, everything we are going to give. PPTs also we will give, don't worry. Okay, at max by tomorrow it will be ready for you. We'll be sending to you. And ask your friends also to join tomorrow. And tomorrow we are going to discuss about the fan in, fan out, timings, diagrams, delays, then multiplexers, encoders, decoders, and PLAs, PLDs, right? Tomorrow's session will be very interesting, so don't miss it. So tomorrow again we'll meet sharp 10. We are going to start because there is no inauguration session and all tomorrow. So directly we are going to start with the module 3 portions. Okay. Okay. So unable to hear voice. Ma'am, can please tell how to write the truth table? Okay. Done. I've done. Okay. So thanks for hearing our sessions patiently. So tomorrow also, please join with us. We will be starting module 3, complete module 3 we will be covering tomorrow. So we shall leave today. Okay, thank you. Yeah.
Thank you all.
Thank you all.
That's fine.
Yes, Nishant, you are asking something. Can I know what it is? Hello? Nishant? Are you there or you left? Okay, I think he's left. Okay, we'll wind up the meeting.
ನಾಳೆಗೆ ಏನಾದ್ರು ರೆಡಿ ಮಾಡ್ಕೊಂಡು ಬರ್ಬೇಕು.
Ma'am, will recorded sessions be provided? Yeah, they are getting recorded and it will be available in the YouTube link. I think YouTube link is also posted. If the link is not there, we'll post the link tomorrow in the chat box so that you can copy down. So the links will be posted in the chat box tomorrow. For the notes and whatever materials are required, we'll post the link in the chat box. Right? All the sessions are getting recorded. Anything else? Shall we end the meeting? Okay then. Thank you all. Have a nice day.